Hey guys, thank you so much for your interest in this course. This course is particularly for Java Spring developers to learn Docker from scratch in detail. I want you to see this as a course to help Java developers to increase their productivity and quality of the deliverables by using Docker in our development process. This is what we are going to do in this course. We will be developing a couple of microservices. We will use Docker to create the dependencies like databases in a matter of seconds with the predefined test data. You will see how it helps us to quickly start with our development process. We will also be packaging our application using Docker. We will be running multiple instances of our application, databases, a proxy server. However, the whole setup will be accessible via one single port by using Nginx to do path-based routing, load balancing, etc. to simulate a mini cloud in our machine. We can easily bring this entire infrastructure up and down in a few seconds whenever we want by using Docker Compose. So this is the course structure in detail. So first we will be learning Docker from scratch, just Docker. The main aim of this section is to familiarize ourselves with the Docker and its various commands. How it helps me as a developer to quickly bring some applications like if I need Nginx, Postgres, Mongo database, etc. That is the idea. Then we will be moving on to developing a microservice using Spring Web Flux. Here I would be using Spring Web Flux, but if you are not comfortable with the Web Flux, you can use Spring MVC if you like. Developing a microservice and a packaging as a Docker image, that is the aim of this section. We will also be using Docker for dependencies like in the Mongo database, Postgres database, etc. with the predefined test data. So how I can quickly bring this up, all the dependencies I need using Docker to increase my productivity. That is the idea. Then we will also be learning test container, a Java library which uses Docker behind the scenes for us to write better integration test to improve the quality of my software. Then we will be learning a mock server by using Docker. That is, in the microservice world, we will be developing multiple microservices, multiple teams will be involved. Sometimes one microservice might depend on another microservice. So even though the other team is not yet ready with their development, you can start early development by using mock server. Okay, so that is the idea. Then API gateway, how I can use Nginx to simulate a fake cloud, a mini cloud in my machine to do path-based routing, load balancing. Okay, we can do all the cool stuff. That is the idea here. I'm also planning for a cloud native application development series of courses. So definitely you cannot cover that in one single course. So the Docker is the very first topic in that series. Later we will be talking about Kubernetes, Helm, Service Mesh, all the various cloud design patterns, etc. I have some assumptions. I assume you are comfortable with the way in which I speak. Then I assume you know Java and Spring because we will be using Spring Web Flux to develop a couple of microservices. If you are not comfortable with the Spring Web Flux, that is fine. You can use Spring MVC. Okay, but I assume you should be familiar with at least one of these. Hey guys, this section would be a super short section. I would personally like to learn any technology from scratch, like why it was created in the first place, what was the problem it's trying to solve. So this is very important to me. If you also like to know, then stay in this section and continue. This is a theory section. If you do not like theory and find it boring, then please go to the next section where we install Docker and we will have hands-on, etc. Okay? Okay. In the good old days, before cloud, in an organization, there could be multiple teams. Each and every team, they are responsible for their application, and these applications they work on, they will have some assumptions or dependencies, like one team might want to use one version of Java, the other team might want to use another version of Java. So, in order to isolate these applications from one another and to avoid any kind of dependency conflict, they used to buy hardware, physical hardware. They will place order, wait for their arrival, set up the application, run, monitor. This is what they used to do. Then virtualization came into existence. That is, here we buy a big server with plenty of CPU and memory. We install operating system, then we install hypervisor. Hypervisor is a software which provides virtualization. Then using that, we create VMs for each and every application. Then we set up the application. So it provided nice isolation for these applications. People love this idea. However, it was not really efficient. Why? Because here we have CPU and memory. This operating system, this hypervisor, these VMs, they all need CPU and memory. So most of the resources were used by these applications. So the actual application which we wanted to run were only using the leftover CPU and memory. You're getting right. So this is when a really smart guy, Solomon Hykes, introduced Docker, and he completely changed the way in which we package and run the applications now. Before we talk about Docker, I want you and me to be on the same page. Let's talk about kernel. Kernel is the heart of the operating system. When a server or system starts, it's loaded into the memory and it acts like a bridge between the application and the hardware. Kernel is something like a car chassis. Okay, the frame, wheels, engine, everything is there. It is the main part of the car. It will work, but we do not have the interfaces like steering wheel, brake or accelerator, so that we cannot use it easily. So what we do is that we add a layer on top of it with a set of utilities. For example, you cannot use kernel directly, so we add a layer with a set of utilities like your home directory in your Mac, Windows, Linux, a browser, a terminal, all these tools to make it easy for you to use the machine. The whole setup then becomes operating system, okay, in a high level. So OS is the kernel plus the layer. Okay, we can also say that OS is kernel. Yeah, that is also right, but kernel plus there is one extra layer here. Okay, so remember that. Linux server has various flavors like Ubuntu, Fedora, CentOS, Alpine. So what is the difference among them? Are they not different OS? Actually, all these various Linux distros, they all use same kernel, only the outer layer is different among them. For example, this is equivalent to the various car models we have. Honda has Civic Coupe, Civic Hatchback, Civic Sedan. So they all might use the same car chassis, the same engine. The outer layer is different to make it look different so that it can attract different people. Why we are talking about all these things is mainly because this is when Docker becomes lightweight compared to the VMs. That is, let's imagine that this is your big server. Whenever we install VMs, these VMs, they have their own operating system. Operating system includes the kernel. Then you install your application in that VM. So let's say I'm installing Postgres here I'm installing Tomcat. If you see the whole setup, it's super heavy to run these two processes. On the other hand, Docker idea was, so only the outer layer that makes everything look different. Okay, this is the layer which gives the privacy. Kernel is same anyway. So you know what? I am going to add only the outer layer alone, and I'm going to use the underlying host kernel so that I do not have to bring the kernel here everywhere. So it made it look like an extremely lightweight, and it gives us lightning fast startup time for Docker. Okay, you would be seeing later in this course. Docker sounds like a tool for system administrators. I'm a developer. Should I learn Docker? Front-end developer, back-end developer, SREs, even QA automation engineer, it doesn't really matter which role you are playing. We all use Docker for various purposes to increase our productivity, improve the whole development process. So I would say, yes, every developer should learn Docker. Okay guys, in the previous lecture we were discussing physical servers, virtualization, the story behind Docker creation, etc. In this quick lecture, let's discuss what Docker is. Let's define Docker in simple terms. We as a developer might develop multiple applications like Spring MVC app, WebFlex app, Node.js, maybe some Python, etc. Each and every application has its own set of dependencies. For example, this application might need Tomcat, this application might need a Netty server and a Java runtime environment 11, this kind of stuff. When the application works fine in your machine, you think it's ready to deploy. You work with the SRE, DevOps engineer to deploy the application. During the traditional virtual machine days, you give the instructions, they set up the applications. But it's not working in production or in this server because of some weird exception. We developer will be like, okay, but it works on my machine, right? So this is what we will be saying. This is the problem Docker is trying to solve for us. So instead of working with the system administrators and providing the instructions, you define the application dependencies in a simple text file like this. For example, in order to run this application, you know that yeah, I need a Java runtime environment 11, then I have some configuration in a JSON file, so I need the configuration. Then if I drop the embedded Netty jar, then that's it, my application will work. So you give all the instructions in a simple text file. Okay. Similarly, in order to run this application, I need a set of libraries and utilities. Then I need a specific version of Python. Then if I drop my Python script, it will work. That's it. So Docker will read all this instruction and it will package your application along with all the dependencies, including the runtime. In the good old days, we used to package the application as a jar or var file, right? In the modern cloud native application development process, we take one extra step to package the application as a Docker image. Some of these terms could be confusing, and no worries, as we make progress, things would be much better. So using Docker, you package the application, and when you give the Docker packaged application to another machine, when that machine has Docker installed, you do not need anything else. It will just run fine. You will see later in this course. We do not have to worry if the machine has Tomcat installed or JRE 11 installed, JRE 17 installed. You don't have to worry about anything. Docker will run the app just fine. Let's define what Docker is in a high level. Things might not be still clear to you, but as we make progress in the course, you will understand better. Docker is an open source platform for developers, SREs, almost for everybody in the software industry. So we package the application along with all the dependencies, including the runtime. Using Docker, we can also run the Dockerized application. As it was packaged with all the dependencies, it should be able to run just fine. Docker also provides nice isolation and OS abstraction. That is, whatever the application or process you are running, it will not have any clue about the underlying host OS, the big server OS you are having here, even though it's being shared. It instead, if you ask Postgres what OS you are using, it will assume that this is its OS. If you ask Tomcat, hey, what is your OS? It will assume that, yeah, this is my OS. This is what it will assume. So they will not have any clue that another process is running here. Okay, so they will assume that this is the only process it runs in its machine. We have various flavors of Linux. So in Linux machine, we can easily add only the lightweight layer for Docker to work. But how come Docker works on Windows machine and Mac machine? If you are asking this question, it's actually a great question. Docker shares the underlying host to work. That's what we had discussed. So in Linux machine, it will naturally work just fine. But Docker cannot work on Mac or Windows directly. So when we install Docker in these machines, Mac or Windows, Docker will install a virtual machine actually. It needs Linux kernel to work, but it will just install only one. So no worries. So this is how it has to work. However, setting up is not a difficult process. It's going to be super easy. Just the Docker desktop, the tool, whatever we are going to install, it will take care of everything. So no worries. Hey guys, in this lecture, we are going to install Docker. So open your browser, search for Docker install and go to the get Docker. And that's it. So depends on your operating system. You can go to appropriate pages and download the software, install Docker. Please ensure that your machine meets the system requirements to install Docker. You might need admin rights. That is also important. Okay. If you use your employer provided laptop or desktop, you might want to check this. Okay, please ensure that you read this. This is important. Okay, let's imagine that if I have a Mac, so let me go here. Now depends on the chip. I have Apple chip, so in this case I have to download this. If you have Intel chip, then probably maybe you have to download this. Okay, so download, once you have downloaded, simple, just drag and drop, then you will be seeing this icon, and if you click on this, Docker will start. Okay, similarly if you are on a Windows, again everything will be, you have to just download this and set up the Docker. Okay, so you should be seeing something like an Docker desktop app to start the Docker application. Okay, so everything will be like super simple process. Installation process is super simple. Okay, so again for Linux users, you can follow the same. Go to Linux, install the Docker desktop for Linux. That's it. Once you have installed Docker, you will be seeing this icon. If it's a Mac, probably it might be there in the top, or if it's a Windows, probably it will be there somewhere here in the taskbar. So you should be seeing this whale icon. Okay, so if you click on it, you will be seeing some settings or preferences, depends on your OS. So depending on your OS, so then you should be able to adjust the CPU's memory so that you can allocate enough RAM or memory for your Docker process. You might not need this now. You don't have to touch it for now, but in future, if you have ever if you ever had any issues, you can always come back here and kind of adjust the CPUs and memory. Okay, so just if you click on it, you should be seeing something like this. Okay, under settings. Okay guys, now let's get started. Okay, so at this point you have already Docker installed. Okay, so Again, throughout this course, please ensure that this Docker whale icon is always up and running. Okay, if you're on Windows or Linux or Mac. Sometimes Linux users, if you had installed differently, there is a chance that you might not be seeing this icon. So in this case, Linux users, you might want to check the Docker process or service is running. You can always use service Docker status to check whether it's running or not. If it's not running, just use service Docker start to start the process. Okay, so how the Docker works? Okay, when you install Docker, right, there will be a Docker daemon or Docker server. This is what it's the important thing. Okay, the most important thing. It will be up and it should be up and running in your machine. Okay, so we will be using terminal. So this guy will be acting like a client. This is the client actually. Okay, so using this terminal we will be typing commands. So these commands will be sent to the Docker daemon, and this guy will get the command, it will do its things, and it will respond. So whatever the response it sends, we will be seeing in the terminal. Okay, so this is how it works in a very high level. Okay, so this icon basically says that whether this guy is up and running or not. If you do not see this, probably this guy is not up and running. So in this case, you cannot interact with Docker. So that's why I keep saying that you have to ensure that this guy is up and running. Okay guys, now please launch the terminal or command prompt, whatever it is. Okay, I want you to type the very first command. If you enter Docker and if you type Docker and press enter, now it understands what Docker is, and it says that hey, these are the set of commands we have available for you. So that's what it says. Okay, so you should be seeing some output like this. Okay, so they should work. Let's clear this. And another thing is Docker version. Okay, if you press enter, you should be seeing something like this, a client and a server Docker desktop. You should be seeing two outputs like this. Okay, there is a chance that this guy, it will not show, and it will say that connection refused or something like this. It basically means that the Docker daemon, it's not running, the Docker service is not running, so you have to start. Okay, so this is what it means. So you should be seeing some output like this. Please ensure that whatever the version you have installed, it's like more or less it's same or better than this one. Okay, definitely not older version. So please ensure that you have up to date, or you have better than whatever currently you are seeing in here. Let's clear this, and I would like to let's run Docker compose, one more utility. Let's check. Yeah. Okay, so if you type Docker minus compose, if you hit enter, you should be seeing something like this. Okay, so I want to ensure that you have everything installed for this course. Okay, nothing else. So after this, let's clear Docker minus compose version. Okay, type this, hit enter, you should be seeing something like this. So as long as you have this version or anything newer, okay, that should be fine. So definitely let's not use some very old version. So please ensure that you have at least this version actually. Okay, or anything newer should be fine. Hey guys, in this lecture, let's learn some Docker terminologies. I am also going to list the corresponding Java term so that you can easily relate. Okay, the very first term is Dockerfile. So this file normally will not be having any extensions. For example, you would be creating person.java, right? So here we do not have any extension. It's simply it's called a Dockerfile. Okay, that's how we will be naming this file, capital D. Okay, so this is for this file will contain the human readable instructions for the application to run, like what are all the dependencies you need, what are all the runtime you need to run your application. So you will be providing a simple instructions. Okay, so we'll be creating this. You will see this is almost equivalent to .java, a class file. Normally we will be writing in Java code. So it's a human readable instructions for how the application or how the class should behave, right? This is almost like this. Then build. The build is same like our Java compile or Maven build, same process. So this, as part of the build process, you read the Java file and you will be compiling it, right? Similarly, the Docker will read these instructions and it will be creating the image, a lightweight virtual machine it will be creating. Okay, so that process is called build. Image is output of the build is image. So once it will read the instruction, it will be creating the image. So the whatever the creates, right, the output is image. It's a lightweight virtual machine or a snapshot. Similarly, for our Java world, the output is .class or .jar, whatever it is. Then tagging. The tagging is like version. So here we create a jar version, right? Similarly, here you have the image version that's called tagging. And then the container is nothing but an instance of this image. So if you have a person.class, then you can create n number of persons, right? Using that definition, you can create n number of persons. Similarly, once you have created that image, you can create n number of containers. As long as you have enough CPU and memory, you can create n number of containers. So the running instance of that image is called container. Okay. Then Docker Hub. This is nothing like this is exactly like our Maven registry. So using Maven repository registry, you can share your jar file with the other teams, with everyone, right? Similarly, if you have an image, if you want to share with others, you can go via Docker Hub or some kind of private registry like Amazon has ECR. Similarly, Google Cloud have their own image registry. So you can share your Docker images or store your Docker images, share your Docker images via this Docker Hub. Okay, something like a GitHub. Okay guys, beyond this point, we are going to play with the Docker commands, which are very important and which we would be using in our day-to-day life very often. Most of the commands would be very easy to remember, no worries, except this one. The very first command I would like to introduce is Docker system prune. Just to explain what it does, let's take our Chrome browser. You know that Chrome will keep the browser history, cookies, cache information, etc. It will store those information somewhere in your machine. You do not care where it is, but you know that it stores somewhere. Every now and then we will clear it because otherwise the Chrome will act a little bit weird, right? Similarly, this command is like that for Docker. Docker, in order to do its job, it will create many temporary directories and it will store some information there. The size will eventually grow. So we can use this command to clean up. Please do remember that if you had already played with the Docker in your machine, it will delete those Docker images, containers you had already created. If you do not want to run this command, that's fine, don't do this. But why I am starting with this command is mainly because I want you and me to be on the same page. Let's start from a clean state. Let's play with the commands together so that you and me, we will be seeing the same behavior. Okay, that's why. So Docker system prune, that is the command to clean up things, okay, to get rid of all the temporary whatever the images, containers, whatever you have created, to remove everything so that we can start from the clean state. Okay, so the -AF, the F option is for forcefully remove. Okay, the -A basically says that delete everything including images. Okay, so if you ignore A, if you say -F, then it will not touch the images, it will remove everything else like containers, all those stuff. Okay, so no worries, it will not mess up with your system and all, no worries on that. Okay, so we can run this. Let's start from this. Okay, let's go to our terminal, ensure that the Docker service is up and running. Okay, so the very first command, Docker system prune -AF, I'm going to remove everything to start from a clean state. So if I run this, and it says that, hey, I have deleted this image, deleted this containers, etc. I have cleaned up this much space. Okay, probably if you have not played with Docker before, this is what you would have seen. Okay, now there is nothing else to remove because it has already removed all these things. So okay, I didn't have any temporary directories, all those things. So this is what normally you would have seen. Okay, so this is good. Okay guys, in this lecture let's play with some Docker commands. Okay, so the first command what we would be doing is Docker images. So any Docker command will always start with the word Docker. Okay, so most of the commands will be super easy to remember, no worries. So Docker images, this command will list the list of images you have in your machine. Okay, if you want to create a container of an image, let's say you have one image and you want to create a container instance of that image, you have to say Docker run and give the image name. This is almost like using the new keyword in Java. The run command is like using the new keyword in Java to create a instance of this object. Okay, the class. And if you do not have an image but the image is there in Docker Hub somewhere in the cloud, you can simply say Docker pull. If you give the image name, it will automatically download from the Docker Hub and it will keep it in your machine. Okay, so we will be playing with all these commands. We have a lot more commands. Okay, it's not like we have only these three. So but these are like very easy to remember. These are the very basic commands. Okay guys, go to your terminal. Let's start with our first command, Docker images. Okay, so let's hit enter and it shows only this part. Okay, currently it basically means that I do not have any Docker image. If you had some Docker images, it would have listed them like a table format. Since I do not have any images, it only prints only the header, table header actually. Okay, so that's why it looks like this. Okay, so I do not have anything now. So let's create one Docker container. So for that I need to have some image. So there is one hello world image Docker has created. Okay, just to start from there for playing with that. Okay, let's play with that. So Docker run hello world. Okay, this is one image Docker has created. Okay, so if I do this, then if you see, you will be seeing some image, sorry, you will be seeing some information, sorry about that. Unable to find image locally, pull complete, there is some information here, downloaded, then hello from Docker. Okay, so it basically downloaded that image from Docker Hub and it the container was created, it printed that information, and that's it. Okay, now let's run this command one more time. Okay, now if you see there is this information is not there second time, right? And it directly started from hello from Docker and it exited. So what's going on? Why it was not printing that information second time and why it was printing this information for the first time? So let's discuss. Okay, just to explain what's really going on. So this is what we typed. When we typed Docker images, the Docker daemon, it will check in your local saying that what are all the images it has. Okay, so but it does not have anything. Because of that, it was returning only the table header. Okay, so there were no images. But the Docker Hub, the registry, it might be having hundreds or thousands or millions of Docker images. Okay, now the next time when we say Docker run hello world to create the container, it needs to have that image. So when you say Docker run hello world, it will go and check if there is hello world here. If the hello world is not here, then Docker daemon will actually ask Docker Hub saying that, hey, do you have anything called hello world? Something like that. So if it finds, then it will pull them into your local machine, it will keep it here and it will run it. Okay, so that's why we saw that unable to find image locally, pull complete, all those things. Okay, so it was downloading everything and then it will keep it, then it will run and it was showing the hello from Docker, that information. Okay, when you execute the same command Docker run hello world the next time, it will see, do I have hello world? Yes, I have this hello world, so it will directly run this. So it does not have to go and check Docker Hub. Okay, so this is how it works. Okay, let me clean this. Okay, so I'm going to do 6 docker system prune minus AF to remove everything. Okay, so again I'm going to start from the clean state. Okay, if you want you can also do the exact same thing. Okay, docker system prune minus AF. Okay, now the run command indirectly does the pulling if the image is not there in your machine. Okay, again if I say I do not have anything, so if I do docker run, it will indirectly do the pulling. Okay, so it's not like you have to always use run. You can also, there is a command for pull. Okay, so you can also say docker pull hello world. What it will do is that now it will kind of pull the docker image and it will download it, it will keep it. Okay, so this is almost like our git pull. Okay, same thing, same concept. So it's like git pull. So that's what we have done. Now we have downloaded that image, we have kept it in our local. So now you can see docker images. It says that yeah, there is a hello world image, the version is latest. Okay, it was created 2 months ago, something like that, and the size is 9 KB. That's it, 9 KB. Cool, right? Okay, so this is how it works. Okay, so the run kind of indirectly or implicitly pulls, or you can also pull like this. Now we also see that images, we have this image. Now if we say docker run hello world, now you will not be seeing this pulling all those things because the image is already downloaded. Okay, so now because of that we are not seeing it. Okay, now let's clarify one thing related to pull. If the run command indirectly does the pulling, then should I be using the pull command? Actually, the answer is yes, because once you had pulled the image, then if you are going to keep issuing the same docker run command, this docker daemon will never go and check the docker registry, because whenever you say docker run hello world, it will see an image, it will execute the same image again and again, lifelong, forever. Okay, so let's imagine that you have version 1 image, somebody has updated and pushed the latest version of hello world. Okay, if you keep seeing docker run hello world, the same thing, this is what docker will create a container, then it will show the message, same thing. So the new message, you will never get it. This is exactly like git. Okay, let's imagine that you cloned the master branch, and if you start working on it and if you had never pulled the latest changes, then whatever you have in your local, that's what you will have forever, right? So this is exactly what will happen for docker as well. So if you want to pull the latest changes, you can say docker pull hello world, then it will go and pull the latest changes and it will keep it. So you also will be using pull like once in a while, whenever it's required. Okay guys, now let's shift gears and do something interesting. If you see the hello world image from hello world message from docker, right, it says that if you want to do something cool, maybe you can run an ubuntu container. Okay, so that's what they say. So this is a simple message. Okay, so in order to do that, let's pull the ubuntu image. So docker pull ubuntu. Okay, if you do this, it will pull the docker image for ubuntu, and now it has been downloaded. So now if you say docker images, you have hello world and ubuntu image. It's like almost like close to 70 MB. Okay, so just go. Now I'm going to clear the screen. Now I can, like hello world, I can also say docker run ubuntu, right? If I say docker run ubuntu, it kind of almost immediately exited, right? Let me run one more time. That's it. Okay, if I run one more time, that's it. Okay, so what's really going on here? Okay, so I have the ubuntu image. So basically what it does is that it creates an ubuntu lightweight virtual machine for you. Okay, almost in 1 second. That's it. It creates and it exits immediately, because we do not have anything, it does not know what to do. Okay, we are not giving any task for that ubuntu container to do. Because of that, it starts, oh, nothing else to do, so it basically exits immediately. So using the Docker images command, we can see the list of images we have, right? Similarly, there is a command for to see the list of containers. So Docker ps command, which will be showing you the list of containers you have. Currently, it will show by default the running containers. If the containers have exited or it stopped, in this case, it kind of started and it stopped immediately. That's what happened. To see everything, started and stopped everything, docker ps minus a. Now if you see, this what happens actually. So an Ubuntu container, first we were playing with the hello world, so that's what it is. So I ran this 3 times. So each and every time it created a brand new Ubuntu lightweight virtual machine for me, and it exited immediately. Okay, because it does not have anything else to do. Okay, so let's give some task for this Ubuntu, the container. What you have to do is docker run Ubuntu, just to say date. Okay, so if you hit enter, now it actually opens a Ubuntu container, executed this command inside the container. Whatever the message it receives, right, it prints it here and exited. Okay, so everything happens within a second. This is cool, right? We can keep doing this. For example, if I say ls, it will list the list of directories, files I have in my machine. Probably in Windows, maybe the command could be slightly different. Okay, so you can see this is, I have only one directory called test in the current location where I am. Okay, so this is what I have in my current directory. ls command, this is what it prints. Now let's do the exact same command in Ubuntu. If I say ls, it see what it does. So it again, the docker run command creates a container, Ubuntu container, and executes the ls command inside the container, and these are the directories it sees there. These are the files directories it sees there inside the container. Okay, so this is what happening. Everything happens like in a second. This is cool. Now let's run the docker ps minus a to see the all the containers, including the stopped ones. Now if you see, the first 3 times it was just opening the bash, the shell, and there was no command. Because of that, it exited immediately. But the last 2 times we gave one date command and the ls command. This is the command it executed, and its job is basically done. So because of that, it exited. So that's what it says. Now some of you might be asking this question like, hey, why we have to pass these commands for Ubuntu, but for hello world we didn't do anything. Docker and hello world, that's what we did. But why Ubuntu is special? Why we have to pass this? Remember that each and every Docker image is slightly different. These are all for different purposes. Okay, this the way in which you write your Java classes. Okay, that's how they have also been created. So the hello world, its only purpose is to print the message. So you do not have to pass anything. Okay, so because when the container starts, they say that /hello, looks like maybe it could be a shell script or something like this. It does not really matter. Its job is to print only that message. That's it. That's how it has been created. But the Ubuntu image, on the other hand, it has been created in a way that, hey, if you give the command, I will execute it for you. That's how it has been created. So that's why you can pass different command. It will do it for you. But you cannot do this in the hello world, because its only job is to print this message. Okay, so each and every image is different. But no worries, as we make progress in this course, you will be learning a lot of stuff, and everything will be super clear to you. We had already seen that docker run Ubuntu will create an Ubuntu container. The docker run command has tons of options actually. So we will be taking a look at most of the options. Docker run command is one of the most frequently used command we will be using a lot. Okay, so there are many options, as I had said. So one option which we are going to take a look at in this lecture is -it. Okay, so what it means is that to start a Docker container in the interactive mode, that is, the Docker run Ubuntu will start a container and it will exit immediately, right? Or if you give the command like ls date, it executes that command and it exits immediately. What if you have a list of commands you want to execute? Okay, oh no, I don't want to pass everything one by one. Instead, give me a Ubuntu container, I want to execute all these commands myself, something like this. So you want to interact with the Ubuntu VM or Ubuntu container yourself. So that's when you would be using this option, that is, can you attach the standard input and the standard output. I will be entering whatever the command I will be typing via my keyboard should be going to the Ubuntu, and whatever the output it gives, it has give me a terminal or attach it. Okay, that's what we are seeing here. Okay guys, now let's play with the interactive mode. Okay, so docker system prune -f. Okay, I'm not using AF, -f to remove all the containers, all the dead containers I had. Okay, I cleaned up everything. Okay, so now if I say docker ps -a, I will not be seeing anything because everything has been cleaned up. Okay, so now docker run, if you say help docker run, you will be seeing tons of options actually. Okay, one option is like the I, see, this is for interactive, and T is for allocate a terminal. Okay, a pseudo terminal. Okay, so docker run -it ubuntu. If you say like this, now if you see, it doesn't exit immediately because now it gives you the shell. Now using this shell, you can interact with that container. Okay, so the container is nothing but a virtual machine, lightweight virtual machine. Okay, so now you are inside the Ubuntu container. This is almost like doing an SSH into a remote machine. Guys, please do note that this is not SSH. Okay, we are not doing SSH, but this is kind of, that's what I'm trying to say here. Okay, kind of. So if you do a SSH into a remote machine, you will be given a shell through which you can interact with that remote machine, right? Similarly, now I can interact with this container. That's what I'm trying to say here. Okay, so now I have been given a shell. So now I can say ls command. Now these are the directories I see there inside the container. I can execute this date command. So it shows the date actually. Okay, so now I can create one directory called Vinod. They make directory. Okay, so these are like Linux commands you might be familiar with. So if I see ls, now this directory has been created. Okay, so let me go inside the directory. If I list what are the files I have, I do not have anything because I just created. Now this is where I am. What is my present working directory? It's I am in the /Vinod directory. Okay, now I can create some file. Docker is awesome. Okay, let's create something like this, dummy.txt. Okay, so I am creating a file like this. If I say dummy.txt has been created, I can print the content of this. cat command, it will kind of read that file and it will print what the file contents actually. Okay, so now I have created this file and I am able to see the content of the file. So now I'm interacting with this Ubuntu machine. This is cool, right? Well, if your job is, if you think that if your job is done, you can always exit. Okay, that's it. Now you came out of this Ubuntu machine. This is cool. Now if you want to go back, you docker run -it ubuntu. Now again it has created one container for you. Now if you list, now you are not seeing that Vinod directory. Okay, there is no more Vinod directory. If you see, this is different from this. Okay, so please do note that whenever you say docker run ubuntu, docker will give you a brand new container for you every time. So whatever you had done, everything was there in this container. Once you exited, then basically it's just gone. That's it. Okay, now if you say docker run ubuntu, it creates another brand new container for you. So everything starts from a clean state. It's completely stateless. Hey guys, in this lecture let's play with more docker commands actually. Okay, so let's do docker ps minus a. So this will be giving me all the docker commands. So in the previous lecture we were playing with these image containers. Actually we were I think this is the container in which we had created the Vinod directory, etc. Okay, now if you see, whenever you create a container, right, Docker will assign some random container ID, some kind of unique ID. Okay, then it will also assign some random name for your container. Sometimes this name could be a little bit funny as well. Okay, so these are like some random names. If you want, you can also assign your own name for your Docker container if you like. For example, docker run, you can say like this, minus it interactive mode, that's what you are saying, and minus name. Okay, so you can say, you can call this c1 container 1, something like that. Okay, ubuntu. So basically docker run ubuntu, I am passing few other options, minus it for interactive mode, and I am giving some my own name for this container. Okay, now it opened a shell. Now as usual I can play with this. I can create directory. Okay, so I can list. Now I am seeing this wins directory. Okay, now I exit. If I say docker ps minus a, now if you see, it created the container, some container ID that's random, but the name is c1, whatever the name I had assigned. Okay, so sometimes these names will be useful for you to remember and to access the exited container. Okay, so let me start this exited container, or let me play with this exited container. I can simply say docker start, because the container has already been stopped. It automatically exited. Its job is done, so it exited. If you want to start the exact same container, you can actually you can do this. It's not a docker run, it's a start. It's a separate command. Okay, if you say help, right, there is something weird actually. That is, for the interactive mode we used to say minus it, right? Here you have to say minus aia or minus ai, something like that. This is for the docker start command. Okay, so let me clear this. So okay, let me do this docker ps minus a. Okay, now let me do this docker start minus ia. Okay, now let me give this name. If I give this name, basically, can you start this container in the interactive mode? That's what we are saying. If I hit enter, now the same container has been restarted and I got the shell. Now if I say ls, if you remember the directory I had created, I am able to see. Okay, if I go inside the directory and if I list, I could see the dummy.txt. If I do this, I can see the file content. Okay, so now I can exit. Okay, so similarly I can also okay, docker start minus ia, I can start the c1 container. If I like, I can see the wins directory I had created. Okay, so sometimes if you want to access the exited container, you can do this. Okay, but to be honest, this is not something which we would frequently use. I wouldn't say that I have used this often. No, just for this course, actually I'm using this just to tell you this, but this is not a very frequent use case. Okay, because if I say docker system prune minus f to get rid of all the containers, now everything is, all the containers are gone. So now if you say docker start minus iac1, hey, there is no such container. What are you talking about? So it throws an error. You are getting right. So most of the times we will be creating a new container, we will be doing the stuff, and we will exit. This is the frequent use case, accessing the exited containers and doing this control. It's not a very common use case, but still it's good to know this kind of commands okay, so that if you want to debug, hey, why this, what happened to this container, I want to check. If you want to debug thing for certain cases, you can use this command. Okay. Hey guys, in this lecture, let's play with more Docker commands. In the previous lecture, we were looking at Docker start. So if there is a start, is there any stop command? Actually, yes, that's what we are going to do. So Docker system prune -f to remove all the dead containers I have. Again, to start from a little bit of clean state. So what I'm going to do is that docker run -it minus name. I can give a name, as you know, C1, the container name, Ubuntu. Okay, now a container has started. Now if I go to another terminal, if I say docker ps, I don't have to say ps -a because it's already running. So ps command will also work. It says that, yeah, it up and running. Okay, so it started just 12 seconds ago. Yeah, it's still up and running. ps -a will also work. Okay, so the -a will also list the stopped containers. If you want to see only the running containers, docker ps will give you running containers. Okay, so that there is a container called C1, it's up and running. That's what it says. So if you want to stop from another terminal, something like it has been running, if you want to stop, you can simply say docker stop C1. If you say like this, you will not be seeing anything actually, but it will take 10 seconds because it will try to gracefully stop this actually. So let's wait. Now it would have stopped. Okay, so it stopped. So it we exited in after 10 seconds actually. Okay, so now if you do not like this behavior, if you want to kill immediately, okay, so if you try to rerun the same command, right, I would like to show you this error as well. What it says is that docker run, every time it will create a new container. Now it is trying to create a new container with a name called the C1. Hey, the C1 is already taken by another container, so I cannot assign the same name. Either you have to remove that container or give a different name. That's what it says. Okay, so if you want to start the same C1, you have to use start command. The run, this is what we will be using frequently, oftentimes. This is what we will be using. So if you are planning to use this, give a different name just for that container. That's what it says. So let's give C2. Now this guy is happy. So another container is up and running. If you say docker ps -a, the C1 exited, we stopped, C2 is up and running. So instead of stopping, okay, we can also, there is a command called kill. If you want to kill immediately, just exit immediately, there is no more 10-second wait, something like this, you can simply say like this, it will just exit, it will have killed immediately. Okay, so we can also stop and kill the existing if the container is running, and if you do not want it, if you want to stop it, we can also do this way. Some of you might be having questions like, should I be always assigning a name in order to use this stop, kill command, etc.? It's not like that. Okay, so then it's not like you have to always assign a name. For example, let me create another container. Okay, so now it's a new container. Now if you go and check, okay, there is a new container running with some name. You can also use this name, or you can also use this container ID. Okay, you can also say docker kill this container ID. You can also use this, or you can also copy this guy, and if you use this, this will kill the container. Okay, one cool thing is that let's create one more container. Okay, it's a completely different container now. Docker ps -a. Now if you see, this is exited, it's up and running. Now we can also use any of these actually. For example, 018, can you kill that container ID which starts with the 018? You can also say like this, so it would have killed the container. Okay, so you can also do this way. Hey guys, in this lecture, let's take a look at the docker exec or execute command. This command will look more or less like docker run command, but for a different use case, a slight variation actually. Okay, so this is how the command will look like. Docker exec, you will give the container name and the command. So the Docker will execute this command on this container. If you see, we had done something similar actually, if you remember. Docker run image name command, Docker run ubuntu ls, Docker run ubuntu date. So whenever you use the run command along with the image name, right, Docker will create a brand new container every time for you, and it will execute the command, it will exit, right? This is what we had seen. Exec will do similar thing, but it will not create a new container. Instead, whatever the container name you are giving, right, it will use that container and it will execute that command on that container. Okay, so this is the difference here actually. So this is something like we would be using actually frequently. So let's play with this now. Okay guys, now I'm going to the terminal, docker system prune -f. I would like to remove all the dead containers I had in my machine, so everything is gone now. Okay, so docker run -it name. Okay, I can just give some name, C1, something like that, Ubuntu. Okay, what it will do, it will give me a brand new Ubuntu container. By this time you know this well already. Okay, so ls, I have these directories, so I am going to create Vinod directory. So if I say ls, the new directory has been created. Now let me go to another terminal. I am not exiting, so I haven't exited, so it's still up and running. So if I say docker ps, the Ubuntu container is already up and running. The name is C1. So if I say docker exec C1, if I say date, it executed this date command on this container. Now if you again go back ps, you would be seeing only one container. If I say ps -a, even then you are seeing only one container. So exec had not created a new container. So the date command was executed on this container only. Okay, so the cool thing with the docker exec is, right, it can be used for different purposes actually. So but let's see this docker exec. Now can you list everything you have inside the container? Now I can see the Vinod as well. The directory is also present because it was executed on that container. Okay, now if I let me clear this. Now if I say docker exec help, it has some options like run options. I can also I can attach for the interactive mode. So docker exec -it C1, if I do this, hey, you are forgetting something. That's what it says. So requires at least 2 arguments. If you see, this is the argument, docker exec options -it I gave, container I had given C1, that is the container, and what is the command you are planning to execute, that's what it says. Okay, but here I am not planning to execute any command, but you have to explicitly say that give me a shell here. Okay, because that it expects that, it's not optional, it kind of expects that. So give me a bash, give me a shell for me. So now it gives you the shell. If you see now, if you see 8c88, this is exact same container you have been given now. So this both, I mean in both places, right, both terminals, right, I am accessing the same container. Okay, so let me clear this screen. Now if I list, the Vinod is there. Okay, I can remove this directory, Vinod. I can remove this, Vinod is a directory. So let's say remove rm-r. Okay, I can delete this directory. Now this is not there. Now if I go on the list, it's not there. So if there is a container running already, I can also access the same container in the interactive mode using exec command. Okay, you are seeing that, right? If I use run, it will be always creating a brand new container for me. But if I use exec command with the -interactive mode option, then I can also access the existing container in the interactive mode. Okay, so that I can just see what's going on. Again, this will be useful for debugging purposes. We will be using this in the later part of the courses actually, so no worries. Hey guys, in this lecture, let's take a look at the Docker image name format. We have been using Docker run hello world, Docker pull Ubuntu, something like that. But how Docker exactly pulls that image, from where it gets all those things? Okay, so actually we have to use the image name in this format. However, if you see, there are many optional fields here. So when you say Docker run hello world, what Docker will assume that, oh, this guy has ignored many fields. So basically he's trying to pull the hello world from docker.io/library. Under that username, there is an image called hello world with the latest tag. That is what he's trying to refer. So let me pull that. That is how Docker pulls that image actually. Okay. So let's imagine that you have your own account. Okay, so Docker has its own library account under which they have many images. So hello world is one of them. Because of that, you can ignore this. It's optional. Library is a word, is optional. So if you ignore it, Docker will automatically go and check under the library account. But if you have your own account, you have your username, and if you had created your own image, you have to give your name along with the image name. Only then Docker can locate. It cannot, otherwise it cannot locate that. Okay, we would be seeing all these things, so no worries. Let's say that instead of using Docker Hub, you are storing your images in AWS ECR. Okay, so in that case, actually ECR itself will give you hey, this is the image name you have to use. So that if you look at the image name, right, it will be containing the host information along with the port. Okay, the host, username, the image, the tag, everything you have to use. Okay, so now let's play with this. Okay, so I'm back to the terminal. I'm going to issue docker system prone -af to delete the images. Okay, so that I can start from the clean state. I can demo that. So docker pull hello world. Oops, hello world. Okay, so now if I do this, of course I do not have this image in my local now. Now if you see it pulling from library/hello world, so it automatically has appended docker.io library hello world latest. So that is the image it has pulled now. Okay, let's see what happens if I do this way. Okay, of course this is some kind of random text. If I try to pull this, now it will go and check, and this is the error message I got saying that no, there is no such a repository. Okay, there is no such thing, or it could be a private thing which is not publicly exposed. So if you think that it's a private, do a Docker login. First log into your account, then try to do this. That's what it says. Okay, so that's what it means. So if you ever get like this, either it could be a private repository, you have to log in, or otherwise this repository does not exist. It's not publicly, it's not for public access. That's what it is. Okay, otherwise it's not present. So that's what it means. Okay, now let's go and check the Docker Hub as well. Now go to your browser and search for Docker Hub. So hub.docker.com, that is where we would like to go. And here you can look for hello world. Okay, the very first one. If you look for this, then the hello world. This is the Docker image. We just pull Docker pull hello world. This is what we were pulling actually. So it has 1 billion plus downloads. I myself would have downloaded 5,000 times, I guess. So okay, now if you want to see all the images, whatever the Docker Hub has, so click on the explore button. Now you can see Postgres, Ubuntu, Nginx. Okay, so we would be playing with the Nginx. Let's play with the Nginx actually. Okay, so Redis, Node, MySQL. So you have tons of Docker images actually. Okay, so you can play with all these things. So if you see, there is a Docker image, Docker in Docker, that is the Docker container, right? It has Docker installed, which is cool, right? So you can play with all, you can explore, you can download, pull Docker image, you can play with this images if you like. Okay, now I would like to show you one important thing actually. So let's go to Nginx. Okay, so now if you go to Nginx, if you go to the tag, so these are the list of the image versions they have. So if you say docker pull Nginx, the latest is, it's kind of, it's a default value, so you will be getting this image. Okay, but if you want a different image, for example the Perl tag or something like the mainline Perl, something like this, so they have a different tag for different purposes maybe. So if you want to use any of this version, so this is the command, this is how you have to pull, that's what they say. So if you click on it, it will be copied to your clipboard, you can just simply paste, and it will pull the image with that tag. So you will be getting this image instead of the latest. Okay, or you can also have multiple versions downloaded in your local. Okay, so that is also possible. You can also say docker pull Nginx, you can also say docker pull Nginx stable, all those things you can do. Okay, so now I would like to show you one important thing, OpenJDK. Let's go there. If you go to the tags, now if you see, you have a different the Java JDK. Here it's for Java 11, and you have Java 8, JDK 8, so you have different versions here. Okay, so you can also pull this. Okay, now if you see, there is no latest, I'm not seeing latest here. If you look for latest, yeah, it is there now. Okay, but if you see, this latest was pushed 17 days ago. There is no update after that. It was, last update was 17 days ago. But if you clear this, the newest image was pushed like 4 days ago, which is like this image. So what I would like to clarify here is, latest, it's not by the timestamp. Okay, initially when I was learning Docker for the very first time, that's how I had assumed it, because it would be kind of a little bit confusing thing. Okay, so latest is not by the timestamp or anything. Latest is simply a simple a word or some they attach to the Docker image. It can be anything, literally. I can even say docker pull OpenJDK : Vinod, something like this. So you attach some tag. Okay, so that is how you use. If you ignore that, they assume that it's latest. Okay, so that's how they attach it themselves, and they will push or pull. So latest is not by the timestamp. In fact, Docker people, they could have gone with a different word which will be kind of less confusing. Maybe they would have used a default. Okay, if you ignore this, we would be using a word called default. Okay, they could have gone with that, but instead they went with the latest actually. Okay, but that's totally fine. So latest, it's not by the timestamp. That is exactly what I want you to know. Okay, hey guys, in this lecture let's play with the Nginx. Before that, I would like to show the list of images I have. So I have Ubuntu and Hello World. Okay, so now as you know, if I want Nginx, I can simply say docker pull Nginx. Okay, so it will be pulling the Nginx from the Docker Hub, the latest tag. Okay, that's what I got. If you remember, we had also seen something called a Perl tag. So if you want that, you can also use docker pull Nginx Perl. So it will be downloading that image for you. Okay, so let it download. Okay, so that tag also I have now. So let me clear the screen. Now if I say docker images, now I have both Nginx Perl, Nginx latest. Okay, so if I say docker run Nginx, container for which tag will be created. So there is no confusion on this. If I ignore this, then it will be always latest. Okay, if you want a specific container of this tag, sorry, container of this thing, this image, then you have to explicitly say docker Nginx Perl. Only then the container of this image will be created. If you ignore this, container of this will be created. Okay, so that's how it works. So there is no doubt or confusion in that. Okay, now if you see docker run ubuntu, we have seen this, it will exit immediately because we have not given any command to execute. Okay, but if I say docker run nginx, it doesn't exit. Okay, it keeps running. Okay, so but this is not the interactive mode. If I type, actually I can type, but this is not listening. Okay, whatever I am typing, it's not kind of receiving this as an input. Okay, so what's going on here? Remember that Ubuntu is an operating system, it's an OS. It's there for you, it's there for us to receive the input we give and to execute it, to give us the output. That's how it has been created. That's what its purpose is. Nginx, it's not an operating system, it's a server, so its job is to run, that's it, until you stop. Okay, so it will run forever actually, right? So that's what it does. So each and every image is the container will be different actually. Okay, so the hello world, its job is to print the hello world message. Similarly nginx, it will run the server, that's it, it will keep listening. Okay, now you might be saying that if nginx is running, I should be able to access the home page, right? Actually yes, let's check. Okay, so let's go to your browser. If you say http localhost, you should be able to see, but it says that no connection refused, so it's not running actually. Okay, so let's discuss that now. But if you see, I have not installed Nginx in my machine. Now with Docker, I can quickly spin up Nginx. After I started using Docker, this is how I install this is how I use MongoDB, Postgres, Redis, everything. I do not install the executable. Instead, I use everything via Docker containers. Okay, super easy, right? Okay, so now let's go and check the Docker PS. So the nginx is up and running in another terminal. So this is the name, okay, of the Docker container. So if you remember, there is an exec mode to access the same container. So exec -it. So give the name of the container. So just paste this, okay. And if you remember, the command is not optional for the exec command, so you have to explicitly give. So we are saying that give me a bash shell. Okay, now I'm inside the nginx container. Okay, so now I'm looking for curl. Actually it has curl. So now if I say curl http localhost, if I type this, wow, it says that welcome to nginx. If you see this page, the nginx web server is successfully installed and working. That's what it says. Normally this is what we will be seeing in our browser. Okay, but here I'm able to access this in the container, but somehow it's not working in my browser. Okay, so let's talk about this. Hey guys, in the previous lecture we were playing with nginx and we were able to access the home page inside the container, but in our Chrome browser we were not able to access the home page. So what's going on? So let's discuss. So this is what we had done. Via terminal, when we issued docker run nginx, docker daemon, it looks for the image. If it's present, then it creates a container. We got the nginx container almost started immediately within 1 second. Okay, so nginx started up and running, but remember that containers are virtual machines, like lightweight virtual machine, a mini computer which is running inside your machine. Okay, so this nginx not listening on your host port 80. Okay, so this nginx is not running in your machine. Technically you can argue that no, it's running in my machine. Yeah, that's correct, but it's actually running inside this machine. Okay, inside this virtual machine, lightweight virtual machine. Okay, so it's listening on this port 80, not on your machine port 80. Okay, so because of that, via Chrome browser, when we send a request to localhost like port 80, nobody was listening there. Because of that, we were getting connection refused or page not displayed. Okay, so that's why it was not working. But if you had installed a Chrome browser here and if you had logged into this container, just I'm saying, okay, so we would have seen that home page. That's how the curl command worked actually. Okay, so how to have this Nginx to listen on my port 80 so that I can use this Nginx. I do not have to install Nginx here. Okay, so this is the purpose of Docker container. So how to make this work? Okay, so Docker fixes this problem by using a concept called port mapping. It has simplified this, super simple actually. Okay, so there is a concept called a port mapping through which you can map your host port to a container port. So when you send a request to this port 80, so it will be automatically go to this container port 80 so that you can access Nginx. Okay, so this is it's a run option actually. So this is how it will be. So docker run nginx, then in between you will be passing the run options. So the -p is for port mapping, host port colon container port. I would like to map this host port to the specific container port, something like that. This is how you will be giving. Some of you might be having questions like, what if my container exposes multiple ports? How can I map everything? So the port mapping is basically like an array. You can give the list of host ports, container ports. Okay, host port, container port. So you can keep going like this. Okay, so yeah, let's play with this now. So I'm back to the terminal now. So now the Nginx is up and running. So I'm going to close this. Okay, I am pressing Control C. So if you have a running container like this, you can press Control C to kill this. Actually, if it's not getting killed or terminated, you can always go to another terminal. You can say docker kill the container name. You can give like this. Okay, so let me clean this up. I'm going to say docker run -p. Okay, 80, my host port 80. This is the container port. Okay, I can say like this, Nginx. Now it's running. It does not say anything else, same output. But now go to your Chrome browser. Okay, now if you say http localhost, wow, I can see the Nginx. Okay, so now the Nginx is up and running. Now I can access the Nginx inside the container via the port mapping. Okay, now I'm going to give you a super simple assignment. How can I access Nginx in my localhost 8080? I don't want to access via 80. Instead, I would like to access it via 8080. What should I do? So that is super simple. Go back to your terminal. You can simply kill this and go back here. You can simply map 8080 here. Okay, and if you run now, if you say 8080, now you are listening on port 80. If you go to 80, right, it will show Nginx, but actually I think it's cached. Okay, if you refresh it, it will not work. Okay, so the connection refused. Okay, so actually nobody is listening on port 80. If you say 8080, then you will be getting Nginx. Okay, so what we can do is we can also run multiple Nginx if you like, because containers are super lightweight, right? I can run one more Nginx, let's say p8090 80 Nginx. Now if you see, I am running two different containers. Containers are lightweight. We have already seen this. Okay, so containers are lightweight. So now I am having two different Nginx containers running in my machine. If I say 8080, this will be I'm accessing that container. If I say http localhost 8090, I will be oops. Oh, okay. Sorry about that. It's http. Okay. So 8090, I'm accessing the new container. Okay. So both are up and running. Okay. Now I can go ahead and kill the 8080. If I refresh, probably, yeah, now it's gone. But 8090 is still listening. Okay, so you can play with the Nginx for some time now. Okay. Hey guys, I would like to add a quick note here. Okay, so in the previous lecture we were playing with Nginx. So this Nginx is up and running. The 8091, it's up and running. So here we exited. Okay, so let's clean this up. Okay, sometimes you might want to know what are all the ports the container is exposing. Okay, you might want to know. Okay, so let's say that it's running here. So from another terminal, maybe you can access, you can say docker ps. Now it will show the container. If you see, the container is exposing port 80. It has been mapped to your host port 8090. Okay, so in case if you are running multiple containers and if you want to know the list of ports it's exposing, how it's been mapped, you can use this docker ps command and look for the ports section. Okay. Hey guys, this is going to be another quick lecture. Okay, so in this lecture I would like to show you another run option. For example, if you say docker run nginx, okay, as we know the nginx will start running. We are not doing any port mapping here, but it keeps running. So this is how it will work. So can I close this terminal? What will happen? So can I run it in the background mode? So if you have questions like this, we can always run the Docker container in the background mode, in the detached mode. It's not like you have to always keep this terminal open or anything like that. Okay, we can kill this. Okay, so let me clean this up. If you say docker run help, there is an option for this. If you see, there is an option detach. Okay, so run the container in the background mode. Okay, and it will be printing the container ID for your reference. So we can do like this. So docker run, all the run options you can give. Okay, so you can always say -d. Okay, this is the detached mode. We can always say the port mapping as well. Let's say I would like to map this with the port 7070 80. Host port 7070 is mapped to 80 of this container. So I'm running nginx now. Now that's it. Now it kind of started in the background mode. It printed the container ID. Now I can keep using this terminal for my purposes. Okay, if I want to type the date command, all these things in my machine, I keep going like this. Okay, so but this is the container has started in the background mode for me. So now let me go to the browser. If I say local host 7070, now I can access nginx at the port 7070 because that's how we have mapped. Okay, now you can go back. You can say docker ps. Let me minimize this. Okay, docker ps. Now the whatever the background mode, this container, this is what we see here actually. Okay, so it's running and the 7070 is mapped to 80. Okay, if you want to get rid of this, you can always say da8. If you say kill, so the docker the command, sorry, the container got killed actually. Okay, so now it's no longer running, it's gone. Okay, so you can always stop like this. Now if you refresh, this nginx is gone. Okay. Hey guys, in this lecture we are going to see how to access the container log. Okay, just to understand this, I'm going to run create a container, Ubuntu container, docker run -it Ubuntu interactive mode. So I'm going to create a directory called Vinod, and I'm going to create a directory called Vans. I'm listing this, and I have exited. Okay, so that's it. This is what I did. I'm clearing this screen now. Okay, after 4 or 5 days I simply forget what I did. Now suddenly I remember I would like to, oh, I did something on that day. I wanted to know what I typed, so it was working fine, something like this. Okay, now you can always go back and access the container and the log if you like, assuming you had not deleted the container. Okay, so now you can simply say docker logs. You can give the container name. I find it easy to use the container ID actually. So E74, if you give like this, then it will give you what are all the commands you had typed and what are the output you had received. So you can see all these things. This is cool, right? Actually, I would have used this nginx as well. So docker logs. If I say 87a, then this will give you the nginx logs. Okay, so what are the requested process, whatever you had seen that the terminal, you will be seeing it here. Okay, so this is cool. So this is not like you have to always it's not like you have to always access the exited or stopped container log. Okay, even if it's up and running now, you can always access the log to see that. So let me run nginx in the detached mode. Okay, so now I'm running one nginx in the detached mode. This is the container ID. Right now I can access its logs by using ed 0. Right, okay, so this is what it has outputted. Okay, something like this. So you can always access the log like this. Okay guys, in this lecture we are going to learn something very important. In fact, we would be using this feature a lot throughout this course. Let's say this is my machine. Okay, so I have my own directory structure in my machine. I store all the files, my personal document, project documents. Maybe I'm running a MongoDB, the MongoDB database data is somewhere here, something like this. Similarly, a container, it's a mini computer running here, and it has its own directory structure inside this container. Right, we had seen this. We had said that containers are like stateless. We would keep issuing docker run command to create new containers every time. Then we will also get rid of the dead containers. We would be using them like use and throw plates. Use once, then dispose. This is how normally we use. But what if I would like to maintain the state? What should I do? That is, I am running a super complex algorithm inside this container, and it will run for 2 hours. Then it will find one result. I want to keep that result to be safe. I want to keep it safe. So what should I do? That is where the volume mapping comes into picture. Volume mapping is another run option provided by Docker to bind your host directory to a specific directory. For example, if I would like to map this directory to some directory inside the container, I can map it so that we can exchange files between the container and your host directory. Okay, back and forth. So it's not copy paste. Okay, it's not files are being copied from one location to another location. It's not copy paste. Instead, they are like same directory. Actually, it's mapped like that. For better understanding, right? So you would have seen some ticket counters like this. So this tray is basically shared between like both sides, right? So from this side, we can give the money through which this person can get the money and issue the ticket to that person, right? So basically this tray is basically shared between both sides, right? Similarly, imagine that that side is host, this side is container. So this directory is kind of shared in a way that we can exchange files. So that's what it is. Okay, so this is the run option for volume mapping. So docker run image, in between you would be passing all the run options. So for the port mapping, we had used the -p host port container port, right? Same concept. Here for the volume mapping, you would be saying -v host path container path. Okay, so please use absolute path. Okay, if you have to map multiple host container paths, you can keep going like this, like an array. Okay, so what if this directory is not present? Don't worry about it. This directory will be created automatically for you, so inside the container. So no worries on that. You can see. Okay, so for the Windows users, please do note that you have to give like this, your drive, like D drive then the path, then you map it to the container wherever you want that path. You have to map it like this. Okay, so this is how we have to do. So for the Mac Windows users, right, if you open your Docker desktop application, if you go to preferences or settings, under resources, file sharing, so currently I'm on a Mac, so this is what it says. Basically I can map these directories or any of these subdirectories. Okay, I cannot map /etc. Okay, this kind of stuff. So for the security reasons it will not allow. So ensure that the directory whatever you are trying to map, it's coming under these directories. Similarly for Windows users, you have to enable C drive or D drive, something like this, or maybe you have to add it yourself, something like that. Okay, here check that once. Okay, I would always advise you to map under your home directory. Okay, so something like that, that would be say where you have full permission. So I would say that just do things under your the home directory. Okay. Hey guys, in the previous lecture we were discussing the volume mapping concepts in theory. Now in this lecture let's play with the volume mapping to get the feel of like how it works. Okay, so here I'm using split terminal, so basically two different terminal, but they are in the same path. I'm in the same path in both the terminal actually. So currently this directory does not have anything. Okay, I removed everything, both are same directories anyway. Okay, so what I'm going to do is that I'm going to map this directory, okay, this directory to a random directory inside the container, and we are going to see if we can exchange files or messages, something like this. Okay, that's what we are planning to do. So I'm going to say docker run. Okay, actually I did not enter new line here since it says the split terminal, right? Since I do not have enough space, it automatically wraps, it goes to the next line. So do not hit enter, that's what I'm trying to say. Okay, so okay, it's like one single line command. Okay, docker run -it, I'm trying to do things in the interactive mode. Then -v, this is for volume mapping, as you know, and I would like to map the present working directory, the current directory. This will give me the absolute path. If you are on Windows, in the PowerShell mode, I think it will work. Okay, so the same this thing will work, but if you are using the regular command prompt, I think it might not work there. So in this case you have to give you the absolute path yourself. Okay, then I'm going to map some random directory, so a/b/c, something like that, inside Ubuntu. So I'm creating Ubuntu container. Okay, as you know, Ubuntu doesn't come with this kind of directories actually, so we are going to see it will automatically create all these things. Okay, here I'm going to hit enter. Now I am inside the Ubuntu container. Okay, super fast, right? Okay, now if I list, I can see the directory A. Okay, this is nice. So let me go inside the A directory, cd A. Now if I list, I'm seeing B. This is cool. So let me go inside B. If I list, I'm seeing C. Okay, so if I go inside C, then what I would be seeing, nothing, because this path is mapped to this directory. So both the directories pointing to the same location actually, so they do not see anything actually. Okay, so even here I'm not seeing anything here, right? So same stuff. Okay, so now I can create a directory called hello, something like that. I have created one directory called hello inside the container and a/b/c here. So since I have created here, then the host that should also be seeing the same directory, right? So we can list it now. Wow, we are seeing the hello directory here. This is cool. Now what I'm going to do is that I'm going inside the hello directory here, and I'm going to create a file. I'm going to say hi host. I'm going to say like this, and I'm going to put it under message.txt. And basically what it means is that I'm creating a file called message.txt, and I'm writing this content inside this file. Okay, this is what it does, nothing much, no worries. Even if you are on a Windows, this is a Linux container, so you should be able to do it actually. Okay, so you can do this. So this file should be present here. So if you see cd hello, if you go inside cd hello, okay, and if you see the file is present, wow, this is cool. Okay, So okay, maybe you know what, I'm going to open this file. If you are on a Windows or Mac, just open this file in your favorite editor. I have installed VS Code, so I'm going to open this file. Okay, if you see, I am seeing the hi host. Okay, now for which the host can respond with hi container, how are you? Okay, something like that. Okay, I'm saving this and I am closing this. Okay, now the host typed some message. Okay, now let's see if you can see that message inside the container. Okay, so we are seeing that message. Okay, maybe because of the new line, I think we are seeing one extra space here, but no worries, you know the concept, you know what's going on. So hi host, hi container, how are you? That message, we are seeing the container. Okay, so now if you delete the file here, this will also be missing here actually. Okay, so maybe I can, let's come back. Now let me remove this hello. Okay, so if I list, I do not have anything. So here also I will not be, okay, because the file has been deleted, so it's kind of, it throws that error. So if I come out, so there is no hello directory here. Okay, so now we can see, now we can share files, we can create directories, we can share messages between host and the container, like this. In the previous lecture, we were playing with the Docker volume mapping. Okay, so now I'm in the same location actually. Okay, the same playground, this directory, and I have mapped this the same directory and the /a/b/c Ubuntu. Okay, so this is where I am actually. Okay, so now what is the purpose of this? Why are we doing this actually? Okay, so how it will be used in the real life. So let's imagine that I am running a database container, something like a Postgres or MongoDB. Okay, so if you start using the Docker container for your databases, so where do you think that the database will store its files? So definitely it will be storing in some file system, right, inside the container. But if you stop the container, if you get rid of the container, right, you'll be losing the data. So what we can do is we can map that the wherever the container is storing the files, right, we can map the directory with your host path somewhere, so that it will be, the data will be always safe. Even if you get rid of the container, the data will be safe somewhere. Okay, so that is why we are doing this volume mapping. Okay, so let me go a/b/c. Okay, so now this is what I have mapped, and this is the location, the host location. Okay, so now I'm going to do the one simple thing. This is db. Okay, I'm writing this inside a db.txt file. Now I'm seeing this here, db.txt, and I should be seeing this here as well, db.txt. Okay, okay, so this is cool. Now, so what I'm going to do is that, let me read this file, it is there. Okay, now let me exit this container. Exited. If I say docker system prune minus f, I'm deleting everything. And you know what, I'm also going to delete all the images, everything. Okay, I deleted everything. Now if I say docker images, nothing is there. If I say docker ps minus a, no containers are there, nothing is there actually. Okay, now I'm going to start from a clean state. So docker run minus it, okay, minus v, the present working directory, :a/b/c. It's not like you have to always map it to the same directory. You can also map it to D directory if you like, but I'm saying, okay, and Ubuntu. So unable to find image locally, it pulled that image. Now let's imagine that if you're starting the database, now since you are mapped to this, this directory is mapped to this directory, right, it should be able to see that file actually, a b c database txt. You can access like this. Now this is db. So whatever the message it had written, we had written earlier, a brand new container, it's able to see that file and it reads the content. So this is how we can maintain the state. We can make it stateful if we like. Okay. Hey guys, in the previous lecture we were discussing about Docker volume mapping. Now let's see some practical use case of this volume mapping using Nginx. Okay, if you go to Docker Hub, the Nginx, if you go to description, right, you can get a lot of good information here. Almost each and every Docker image, if you go to description, they will tell you how to use it, all those things. Okay, so each and every image is different. Okay, so here what they say is that if you see hosting some simple static content, so looks like this is the host path. It can be anything. Okay, this is your host, but the container Nginx seems to be expecting the files in this location, user share Nginx HTML. This is where it seems to have the files actually. Okay, so that's what they say. So okay, so let's see, let's try to go to this location and let's see what's going on here. Okay, okay, so I'm going to run Nginx. Actually, I'm going to run Nginx in the detached mode. I'm going to assign some name as well, C1 Nginx. Okay. Oh, okay, I had deleted all the images. Okay, it's downloading. Okay, so it has started. Okay, so now let me use docker exec command so that I can access the same container -it interactive mode and C1, that is the container name I have just assigned, and give me a bash shell. That's what we are saying. Oops. Okay, now I am accessing the same container. Now if I go to user share Nginx, okay, HTML. Wow, so this is the path from which Nginx seems to read the file. Okay, so it serves the index HTML. So let me try to read the file. Okay, so welcome to Nginx. Everything comes from this location. Okay, so what we are going to do is that I hate this file. Okay, so instead we are going to create some cool file ourselves and we are going to serve that as index.html. Okay, so that is what we are going to do now. Okay, so for that, okay, let me exit. Okay, and if you remember, it's still running docker kill C1. Okay, I stopped Nginx. Docker system prune -f. Let me delete everything. Okay, so now let's create one index.html in our host. Let's make it serve via Nginx. Okay, so in this location, the host directory, what I'm going to do is that I'm going to create one index.html. So I'm going to use Visual Studio Code, but you can use any of your favorite IDE, doesn't really matter. Okay, so I'm creating index.html file here. Okay, so it's opening, okay, in a different window. I'm bringing it here, so now you should be able to see. Okay, so we don't need HTML body, all these tags. I'm simply going to use h1 tag. Okay, just to keep things a little bit simple. Okay, I'm going to write this is new index HTML coming from your favorite host. Okay, let's keep it like this. Okay, so that's it. I have created this file. Oops, I forgot to say. Okay, save this file. Okay, so if you see index.html there, and if I read this coming from your host. Okay, so that's it. We have some message here. Okay, okay, so now what we are going to do is that in this terminal, I'm going to start a new Nginx container by mapping this path. So docker run, as you know, okay, we have to do port mapping because Nginx, we already know this, then only we can access. So 80:80, I'm mapping this, and v volume mapping. So the file is in this location, both are same directory, as you know. So present working directory : I cannot do a slash b slash c and all because Nginx seems to read from a specific location. Okay, so you have to map the exact same path. User share Nginx HTML. This is the location. So whatever the file I have, just put it there. Okay, or basically both are same directories. That's what we are trying to say. Nginx. Now if you do this, Nginx will start. That's it. Now let's go to our browser and go here. Let's say localhost. Let's hit enter. Wow, this is new index.html coming from your favorite host. Okay, sometimes you would have played with this, guys. Sometimes it would be caching things, so just refresh it quickly a couple of times. Okay, so this is new index.html coming from, see, this is cool, right? Hey guys, in this quick lecture, I would like to show you one more thing about the volume mapping, that sometimes we do not want to share the entire directory with the container. I might want to share only one single file from a directory. Okay, so this is what we are going to do. That is, I have the split terminal as usual, so I am the same path. Okay, so now if you see, I have the index.html, hi.txt, hello.txt, some 3 files I have in this directory. Okay, so now here in this terminal, what I'm going to do is that I'm going to share just one file. Okay, my interactive mode volume mapping. So from the present working directory, I would like to share only index.html, nothing else. Okay, in a slash index.html, something like this. Okay, so whatever the index.html I have, I would like to map it with in this path, in the container of Ubuntu, whatever I'm going to create. That is what I'm sharing, I'm saying here, nothing else. Okay, so now if I hit enter, of course I can see the A directory. Now if I go to the A directory, right, if you see, I have the index.html file. Okay, whatever I had created, it's here. Okay, we can the same index.html we had used for Nginx, if you remember, the same file. Okay, so now it's here actually. Okay, but even though we have hi txt, hello txt, it's not coming, it's not here actually, if you check. Okay, the files now only I have index.html. Now let me create some file here. Okay, let's say this is container, something like that. I'm creating c.txt, some file here. If I look for it, yes, index.html is there, c.txt is also here. Now if I check here, the c.txt doesn't come here. Okay, so yeah, this is how it works. So if you want to share only a single file, yeah, that is also possible. Hey guys, in this lecture, let's see how to share our host directory, all the files whatever we have in our host directory with the container in the read-only mode, because we do not know what the container does. Okay, sometimes you might be pulling a Docker container from some source, it's not developed by you. Okay, somebody gives you, hey, can you run this container, something like this, but what if the container messes up with your file system? You shared this directory, but these guys, they deleted all the files in the directory, so it will be gone here as well, right? So you might want to be safe, so you want to share all your file directory content in the read-only mode so that these guys cannot delete it. Okay, so that's what we are going to demo now. So let me exit. We can use these same files actually. Okay, now I'm going to docker run -it -v. Okay, so I'm going to share the current working directory with the directory a/b inside our Ubuntu container. Okay, now if I didn't, okay, I'm not using the read-only mode now, but I'm going to. Okay, but if I go here a plus b, oops, cd a b, if you check, I have all the, if you see, I am having all the files. Now I can delete this file. Okay, we have already demonstrated this. I can delete this file. So this is not good sometimes. If you see, the hello.txt is gone. Okay, now what I'm going to do is that to make this as a read only, just append :ro. Okay, we are saying that it has to be mounted in a way that it's a read only file system. That's what we are saying. Now if you hit enter, it's a brand new container again. So now you can see, you can go cd a. Now I'm inside the B directory. If you see hi txt index.html, I'm seeing both files as I'm seeing in the host. Okay, now if I try to remove hi txt, it will throw an error saying that no, it's a read only file system, but I am allowed to read the file. Okay, so I can read the file, I can play with the file, etc., but I cannot remove these files. Okay, so let me see if I can create a file. This is container, something like that. Okay, so I cannot create a file as well. Basically, it's a read only file system. Okay guys, in this lecture we are going to learn another important concept. In the real life, one machine can talk to another machine via network, right? If Docker containers are like VMs, if they are like mini computers, can they talk to each other? Actually, yes, Docker containers can talk to each other. Docker provides a concept called a Docker network, using which we can do that. All these containers are connected in a network. By default, when you create multiple containers in your machine, so these are like the multiple containers currently you are running in your machine. So what Docker will do is that it will place them in a default network. Okay, it's called a bridge network. Okay, it's a default bridge, you can say like that. So it will place them in the default bridge network, so using which one container can talk to another container. However, there is a problem with this approach, that there is no name server involved. Because of that, what will happen is this container can talk to this container only if this guy knows its IP address. You're getting right? So all these containers can talk to each other only if they know their IP addresses, other container IP addresses. The problem with IP addresses is it's not really reliable, because whenever you delete container, recreate container, Docker will assign random IP addresses, so it cannot rely on that. However, this problem can be fixed. So before we play with this, let's quickly discuss the few network drivers. Actually, there are few network drivers. By default, Docker uses something called bridge, using which it creates a default network. This is what we were discussing. Using this network, all these containers are connected, so one container can talk to another container if they know its if you know the IP address. Okay, this problem can be fixed by creating our own custom bridge network. Okay, so we will be doing this. There are also few other network drivers, so this is not applicable for us, but let's quickly discuss. Okay, so when you say none, what Docker will do is that it will not place that container as part of any network. It will disable all the network. So that's what it means. So it's not something like a frequent use case. So maybe it's for bad jobs, this kind of stuff, but it's not for us. Okay, we can assume like that, so we can ignore it. Another type is host. It works only on Linux machine. It doesn't work on Mac or Windows. Okay, so it's been documented if you go and check in the Docker documentation under network section. Actually, what it means is that we are telling Docker that, hey Docker, do not create your own network. Place this container as part of the machine, something like that. Okay, as part of the host network. That's what we are saying here. Okay. So again, this is not applicable for us, so we are going to ignore it. Okay. Another type is overlay. This overlay, right? This is something like important, I would say. Using this, one container in one machine can talk to another container in a different machine. Okay. So this is where the overlay will be very helpful. So definitely this is important, but we will be covering this slightly differently using Kubernetes. That is what the Kubernetes is going to do. Actually, Kubernetes is going to do a lot more than this, but this will be covered as part of Kubernetes course actually. Okay, so let's ignore this is super important, but we are not there yet. So let's focus on Docker in this course. Let's move on to overlay and all later. Okay, so now this is the only thing which is going to applicable for us now. So let's play with this. Okay. Okay guys, so in this lecture let's see how to create a network for our Docker containers so that they can talk to each other. First, let's try to talk using the default bridge network. Okay, for that what I'm going to do is that I'm going to run a simple nginx. Okay, I'm going to assign name for our server, and thus I'm going to call this nginx. Okay, or if you want to call this something else, that's fine as well. I'm going to call this nginx. So docker run nginx. I'm in between, I'm giving these the name option. That's it. So now nginx is up and running. Okay, now in order to let's go to docker run -it ubuntu, just run in the interactive mode. I want to ping this, or I want to access the home page of the nginx from this container. Okay, unfortunately this Ubuntu, right, does not have curl or ping, all these utilities. This does not have actually. Okay, we can install it ourselves, but as you know, once you come out of this container, it will be gone, right? So because of this reason, right, I have created a separate Docker image and I pushed. So I want you to pull Docker pull. My account name is Vince Docker because it's not part of library. Okay, it's not part of library. Because of that you have to give, if you remember, you have to give the username. Okay, slash, then this is the image name. It's called util. That's how I had named. So check the spelling once. It's VINS docker / util. Okay, so I'll tell you how to create our own images and later we are going to cover it. So no worries on that. Okay, so now if you pull, then it should be pulling the Docker image. Okay, now we have this Docker image. Okay, so now using this, I'm going to create a container of this. Using this, I'm going to access our home page. Okay, so for that, if I say docker run -it Vince Docker util, create a container of this image. That's what we are seeing. So now if I say ping, it knows. Okay, so ping nginx. If I say it's a name or service not now. Okay, what are you talking about? That's what it says. There is no such thing. Okay, but if I say Google, it knows Google actually. Okay, interestingly, it knows Google, but it does not know nginx, which is running just here actually. Okay, so now some of you might ask, how come it knows Google, but how come it does not know this guy? Okay, if you see, if you go to cat this location within the container etc resolve. Okay, check this name. Okay, if you hit enter, so there is a name server actually. Okay, so this is my home for my home network. This is the DNS configure, the name server. Okay, so probably you might be seeing something similar for your you should be seeing something similar in the Docker container. Okay, so because of that, it knows Google, but it does not know this container nginx and all. Okay, so this is why it's like this. Okay, let's exit. Now what I'm going to do is that I would like to know the IP address of this container. I can access it actually. So there is a command docker inspect. Okay, inspect nginx. The nginx is the name of the container, not the image. Okay, it's a, maybe I should have named it differently, but that's fine. So it's a name of the container. Now if you hit enter, interestingly we get this. Okay, in that bottom. Okay, so if you see, actually it's a huge file, I mean huge response, you can check. Okay, but it enter network section, it's a bridge network, and this container IP address is this. That's what it says. Okay, so this is interesting. Let's copy this guy. Okay, so now let's go back to docker run -it Wins Docker util. Let's create another container. Now if I say ping using this, now see it's able to ping. Okay, now let's clear this. Now if I say curl, if I give the IP address, see I am accessing the home page. Okay, and it also sees that it received a response. Sorry, it also received a request. That's what it logs actually. Okay, so this is how the bridge network works. So it does not, there is no name server for this the default bridge. So because of that, only if you know the IP address, one container can talk to another container. Okay, but we are going to create our own network and we are going to fix this problem. Okay. Hey guys, I would like to add this quick note if any of you have this question. So if you remember, when we ran Nginx for the first time, when we were doing the port mapping, okay, only then we were able to access the home page in our browser. Now we did not expose any port here. How come this container is able to access the home page of Nginx? For most of you, this might be clear, but some of you might be having this question, but so I thought of clarifying this. Okay, let me exit. Since that container is already running the Nginx, we can simply do docker ps. Now if you see, right, Nginx, it always exposes the port 80. Okay, but or anyone can send the request to Nginx, we can see the home page, but my machine, it's not part of the Docker default bridge network. Even though it's running inside my machine, I cannot access that default network, okay, the default bridge network. So that's why we had to do the port mapping, etc., to access in our browser. Okay, but this container is part of the network. Because of that, this guy can easily send a request to this IP address. So since the 80 is exposed, it's listening on port 80, so that it can process and receive the request and send the response. Okay. Hey guys, in the previous lecture we were playing with the default bridge network. Now in this lecture we are going to fix the name issue by creating our own custom bridge network. Okay, but that process is super simple actually. So I'm going to exit this Nginx, kill the Nginx. Okay, I'm going to do a docker system clone -f, so that to delete all the containers. Okay, let me clear this screen. Okay, so now everything is gone. Okay, let me do docker ps. Okay, nothing is running. Good. So creating network, guys, it's super simple. So docker network create, that's it. This is the command. Okay, so you have to give some name. So maybe let's call this a dummy network, something like this. Okay, you can give your name, whatever you want to give, you can give. I'm going to simply say dummy. So this is the network. Okay, if you want to see the list of networks, right, you can say docker network ls. So it will kind of, okay, sorry, docker, okay, docker network ls. Okay, so we have the host, the none, we have seen this, there is a default, this is the default one, and we have created one dummy network using the bridge. Okay, so okay, now what we are going to do is that you are going to run the Nginx as usual, but we are going to give the name as Nginx or give different name. We are going to use the network we had created. Okay, so it's one of the run options, so that's going to be dummy. Okay, let's keep it like this because that is a name we had given. So that's it, super simple. Now Nginx is as usual up and running. Okay, now we are going to create our wins docker, the util, that instance. Remember that even this container has to be part of the same network. Okay, so network dummy. Now I have to say wins docker util. Okay, now before we ping or anything, let's go to the etc resolve kind of. Okay, if you see, now the name server is different. Last time it was showing something like 192 or something like that, if you remember. Now if you see, the name server is completely different. This is Docker's name server, okay? So now this guy knows what Nginx is. If you want, you can simply say ping Nginx. Now you are getting the response, right? This is cool. Okay, now if you say curl, of course we will be getting the response. Okay, so now you can simply, so one service can call another service just by using its name. Okay, this is not the image name, this is the container name. So just by using its name, one service can talk to another service, so we don't have to remember the IP address, all those things. However, you might kind of a little bit find it annoying, saying that I have to do this one extra step. No worries, this can be super simplified later, okay? But yeah, we are learning everything slowly, step by step, okay? But we will come to that part in that next section actually, okay? Not next lecture, next section. So once done, I'm going to exit, and I'm going to exit here as well. So I'm going to do a docker system prune -f. So if you see, this command deleted the containers and it also deleted the network. So usually the system prune command, right, it will delete all the unused stuff and it will not touch the image. Okay, it will keep the images whatever you have downloaded as it is, but all the unused stuff will be deleted. Okay. Hey guys, so far we had been using the Ubuntu image, Nginx image, but we had never created our own image. So in this lecture, we are going to learn the commands we have to create our own Docker file and a Docker image. Okay, so that's what we are going to discuss. Creating a Docker file, it's a super simple step, guys. Okay, we have only these few options. Actually, we have a lot more commands than this, but these are the commands which we will be frequently using. And if you know this, right, you can create your own Docker file. Okay, so these commands are more than enough for us to do our job actually. Okay, so Docker file, it's simple text file. If you remember, as I had said earlier, it will be capital D, and this is how you will be naming your file. There is no extension. It's not like .txt, .java. There is nothing like that. Okay, no extension, just a simple Docker file. Okay, and you would be writing the file like this using these commands. Okay, so now let's discuss. If you take any Docker file, guys, okay, this will be the first statement you would be seeing. Okay, you would be seeing the first statement as you see here, from image. So the base image for your Docker image. Okay, any image, whatever the image you are going to create, right, you would be using another image as the base image. On top of that, you will be adding your requirement. That is, take wins docker util and do all these things. If you do all these things, yeah, that is my image. That is how you would be giving your instruction. Okay, you can use anything actually. You can say from Ubuntu, from Nginx, whatever you want, you can use it. Okay, something like that. So this is how we would be using. So the from that image, that would be the first statement in any Docker file. After that, it's not like, oh, so in this case, this will be it should be the second statement. It's nothing like that. After that, you can change everything, but this should be the first statement in your Docker file. Okay, that's how it starts. Okay, then add or copy. You can use either of these. Okay, so what it will do is that it will copies the directories or files from your host and into the Docker image you are creating actually. So let's say if I am having this file txt in my current project, this will copy that file and it will place it inside the image. Okay, it's creating. Okay, so when you create it, right, it will copy the file and it will name the file as that file txt, something like that. If you want to give, you can also give the same name, but you can also give a different name. That's what I'm trying to say here as part of this. Okay, so if what's the difference between add and copy then? Okay, both are more or less same. Okay, most of the times you can use copy actually, but add can also accept URL. So add can also accept the URL, so it will download the content and this will put that content inside the image. Okay, so you can use any of these actually. Then run command. The run command is a command to be executed during the image build process. So suppose Win's Docker util, okay, inside this image, I would like to create one directory. Okay, so if you want to do this, right, you would be saying run make directory D. Okay, so this will ensure that this will be creating a directory called D. Okay, something like that. So that's where the run is useful. Command to execute during the image build process, remember that. Okay, then env key value, so it sets an environment variable. For example, if you want to set an environment variable called Tomcat home, Nginx home, or Java home, something like that, then you can use this. Super simple, right? Work directory, it creates a default working directory, okay, when the container starts. Okay, something like that. If you ignore it, right, the root directory that would be that would be used. For example, why I am saying work directory here is mainly because if I say work directory a/b/c, even if the directory is not present as part of this, during the image build process, this directory will be created, okay, automatically for you. Once this directory is created, beyond this point, whatever is happening, right, it will be happening under this path. That is, if I say work directory ABC, after creating this directory, add this file txt, so it will be copying this file from my project, my current host, and it will be placing this with this name under this C directory. You're getting right? If you do not use work directory, this file will be copied under the root under the root directory, which we do not want to use most of our time. Okay, we do not use the root directory, right? We always have our own home directory actually. So we create some workspace or home for inside the Docker container, so inside the image. That's what we are trying to do here. Then expose port, it's obvious, it exposes port 8080, 800, whatever, or 8090, whatever you give. Okay, then command or entry point like add copy, we have here we have two options to command to be executed when the container is created actually. Okay, so yeah, for example, if you want to start your Java application, let's say Java jar app jar, then you would be giving like this. Okay, there is a small difference. I will explain that later. Okay, so now hopefully this is clear. Okay, so now let's create our own Docker file so that we can understand this better. Hey guys, in this lecture we are going to create our own Docker image. Okay, so let's start by creating our own Docker file. Okay, so what we are going to do is that we are going to create a simple hello world kind of a Docker image. Okay, that's a starting point, but we will be creating a few more Docker images later in this course, so no worries. Okay, so let's start with creating some simple text message, message what you want to display when the container creates. Okay, let's work on that first. So for that I am going to create one simple text file. I'm going to use VS Code actually. VS Code welcome text. You can use any of your favorite editor. Okay, here if the code is a command using which I can launch VS Code. Okay, maybe you have Notepad, TextPad, whatever your favorite editor, use it. Okay, so here I'm going to say hello world, I am learning Docker, so far great. Okay, and let's save this. So this is our welcome txt, right? If I okay, so here I create this file one in an empty it was empty. Now I have created this file. I would say have one empty working directory and work on it. Okay, so yeah, now we have created our welcome text. So this is the message we want to display when the container starts. Okay, let's assume so. Now let's work on creating our Docker image by creating our own Docker file first. For that, we have to create this file, Docker capital D, Docker file, no extension, no nothing. Remember that. Again, it's another text file anyway. So I'm going to use VS Code. So this guy says that you want to install extension. No, I don't want any extension. Okay, so now what we are going to do is that we are going to start with from. So what is the image you like to use? I would like to use Ubuntu image. Okay, okay. Now I would like to have one work directory. What we can say? We can say I can say whatever I like. So you can also say anything you like. Okay, I'm going to say wins welcome, okay, something like this. This is the working directory I'm going to create, so you can say whatever you like. Okay, now I'm going to say add, or we can also say okay, add copy, whatever you like. Okay, welcome txt, because this welcome txt in the current project same workspace. Because of that I can say like this. So do not try to copy everything from the root directory. Do not do like this. Normally we do not do like this. Okay, so we will be copying whatever we have under part of our project. Okay, something like that. This is what normally we do. Okay, so add welcome txt and place it as a welcome txt. You can say like this. So where do you think that it will copy? It will copy under wins welcome. This is how it will copy actually. Okay, now what else you want to do? If you want to do something else, you can keep doing, but in our case this is what we want. This is our job is done. Basically, once you have copied the file, that's it. And when the container starts, we would like to show that the message. So command, this is what we have to use. You should not use run. Run is the command to be executed during the image build process. Okay, command is for when the container starts, actually when the container is created. So when the container is created, read the file and display. So yeah, this is what it is. Okay, so now that's it. Save this. Now your Docker file is ready. So let's close this, and if you see, you should be seeing both Docker file and welcome text. Now let's create the Docker image. So the command is very simple for that. So Docker build, we are building an image, and I would like to give a name for the image I'm building. So for that, there is no name. Instead we have to use T. Okay, the T is for tagging or naming, something like that. Okay, so you have, well, what are you going to call your image? I'm going to call this my hello world. Okay, you can give whatever you like. So yeah, I'm giving like this. And then where is your project? Where is the Docker file? Where is your project? For me, this is my project. This is where the Docker file is. All the project files are here in this location. So because of that, I am giving dot, the current directory. Suppose if it's somewhere else, let's say there is an A directory under which everything is there, I would say, hey, go and check under A directory. Everything is there. That's what I would have given. Okay, so in this case, it's the current directory. That's what I'm saying here. Okay, so hit enter. Wow, this is super fast, guys. Okay, I didn't expect this. So you know what, this mainly because since I had the Ubuntu image, right? Since you said that take Ubuntu and this file, and that's it. That's what we had done as part of our Docker file. Because of that, it created the image very quickly actually. Okay, so if you go and check Docker images, So yeah, we are seeing our image actually. This is cool. Okay, you know what I'm going to do is that I'm going to uh, do a docker system prune -af to delete everything. Let me do this one more time. Okay, I didn't expect that. Okay, let me do this now. Okay, same location, we are going to build the same image. Okay, now the Ubuntu is not there. Let's see. Now if you see, oh, this not there, so it will download Ubuntu. Now it creates a work directory, adds the file, and it says that, hey, I created this, your image, whatever you said. Now if you see, it's naming my image as Docker IO library my hello world. Is it right? See, no worries. Since I have not given my username all these things, it assumes that it automatically appends all these things. Okay, no worries on that. Okay, so if you go to Docker images, it's called my hello world, so you should be able to create a container of this. So how can you create a container of this? Docker run my hello world. Okay, that's it. Wow, so now we are seeing hello world. I'm learning Docker so far. Great, nice. So I can keep saying hello world again and again. This is nice, right? So if you go to Docker ps-a, we can see all the containers it had created. Okay, so yeah, this is cool, guys. Hey guys, in the previous lecture we were creating our very first Docker image, right? Let's continue in this lecture. I would like to show you few things. Okay, once you have built your Docker image, I want you to explore your image, how it is inside the Docker image. Okay, the container, the file, all those things. Okay, sometimes in order to debugging purposes, right, you might want to see that actually. Okay, so in order to do that, first I would like to do the docker exec command. Do not do anything else. Okay, I am not saying, okay, we do not have to run any container. Just type this and hit enter. If you see, it says that docker exec, you will be giving some options and the container and the command. Here it's mandatory. Okay, now if you see docker run, if you see, it's more or less same. Docker run, you will be giving the options. Here you will be giving image. The command is optional. Okay, so now if you remember, we were asking for bash shell by typing bash. Okay, we were always passing this the bash as the command to in order to get the shell. So similarly, even the run command, right, it accepts command. Even the run, that command accepts this command as a parameter, but it's an optional parameter. Here you can also pass the bash to get the shell if you like. Okay, so what I'm going to do is that docker run -it. Let's do this in the interactive mode. Okay, and my hello world, this is our image. Okay, here I'm saying that give me the bash shell. Okay, now I am inside the my hello world Docker image. Take a look at this, where it's placing me when I am entering the container. This is our work directory. Okay, now some of you might ask, we didn't do this for Ubuntu, why we have to do this here, why it's special? Okay, I'll come to that. But now if you want to explore your image, you can ask for bash shell and you can do this. By default it will place you in the work directory. Okay, so present working directory wins welcome. Okay, now if you see welcome text, that file, it's here actually. So this is exactly what we were doing actually, right? So this is we were adding this file. So whenever the container starts, hey, can you do this? This is what we are doing. So whenever we execute this container docker run my hello world, right, basically this is what it does. So automatically goes to the work directory when the container starts, and its only job is to read this, they execute this command, read this file, and once it's done, now here it exits, right? Because of that, it will immediately exit. So this is exactly what's happening every time when we do the my hello world. Okay, as soon as the process is done, docker will automatically do the exit, so it will come out. but nginx containers and all, right? It's a server, it will keep running, it will never do this exit. Okay, so because of that it keeps running forever. Okay, so hopefully this is clear. And if you want to explore your image, all those things, you can do it once it's built, whether it's everything is correct or not, if you want to check. Okay, now why we why we do not have to pass this for Ubuntu, why we are doing it for my hello world. Now let's come to that. Okay, this my hello world, this is the custom image we have built. Okay, its only job is to print this message. Now by passing this, what we are doing is, whatever the command you have, do not do this, instead can you do this. That is what we are saying here. Okay, because of that, when you do this, when you along with this command, when you do this, right, Docker will stop doing this, instead it will give you the shell. Okay, then you continue. But here, since you have not overridden, so here it's that command, whatever the command, reading the file, printing, it prints. Okay, the Ubuntu image, right, the command is bash shell, giving you the shell. That is what its purpose is. Okay, so because of that, when you do this, oh, okay, I do not have Ubuntu, so it gives you the bash shell. Since you have not given any command, it automatically exits. Now if you say date, it will execute that command, it prints the result and exits. Okay, so this is why when you do in the interactive mode, you do not have to explicitly ask for bash shell, because that's what it does. It implicitly gives you that. Okay, or if you want, you can also explicitly ask for a shell. Okay, so both are kind of same here actually. So hopefully this is clear. So now let me exit. Okay, so let me clear this screen. Now we can also do this. That is, if I do not pass any command, it prints hello world. Right, now you can override the command by passing something else. Instead of hello world, can you give me the date? You can also give like this, what are all the files you have in your work directory, can you print it? So ls, so it says that I have welcome text. Okay, so you can also override the existing command, whatever the image, by default the command whatever it has, you can override by passing the command. Hey guys, in the previous lecture we were exploring our Docker image. In this lecture, let's try to rebuild our image by using entry point instead of the command cmd. Okay, so I'm still inside this, okay, this directory here. Okay, so in order to I'm going to update my Dockerfile. So for that, I'm going to use Visual Studio Code to open the Dockerfile. So this is great. Okay, let me close this guy. So instead of cmd command, I'm going to use entry point. Okay, save this guy, minimize this. Now I'm going to say Docker. Okay, we are going to build, right? Okay, remember, whenever you update the Docker file, you update welcome text, you have to rebuild your Docker image. Okay, because it's a snapshot. Okay, now my hello world. If we want, we can replace the existing image. Now we can also have, you can also just put one or two, so you can give any name you like to have as a separate image. Okay, so where is the project context, the working directory? Here, the current directory. So it's super fast, it's done. Okay, now as you know, we can always run my hello world, the image name here I had given 1, so I can run like this. Okay, so now you might ask, hey, this is exactly what we were doing in the previous lecture as well. So what is so special here? Okay, the special here is, if you say date, it will not take those things actually. Okay, if you do this, it will not take all those things. It will always execute the entry point here. Okay, so that is the major difference between entry point and command. Okay, we can also have entry point and command. Okay, so that the command can be used as an optional argument. Either you pass the argument when you create a container, otherwise I will be using this argument. We can do like that, but we do not really have to go that far. Okay, so knowing this basic difference is enough. Oftentimes I always use command. Okay, I do not use entry point. Hey guys, in the previous lecture we were playing with the hello world image. Now in this lecture let's do something as we do in the real life. And I would like to share the steps normally which I would be following. So that will give you some idea as well, okay, for you. So what I'm going to do is that we already have the hello world image, right? I'm just going to comment this Dockerfile, okay? So, okay. So I'm going to comment this. I'm going to take some notes here. Okay, so if I want to create a Docker image, right, out of some base image, this is the process normally I would follow actually. Okay, so here what we are going to do is that we are going to install Java 17 in a Ubuntu image. So that is the process. Okay, that's what our goal is. That's what we are going to do now. So how to do it? So in order to do that, first let's create a Ubuntu container first. Okay, now this is one fresh Ubuntu container. What we are going to install Java 17. So let's go to this site jdkjava.net. okay, you might be seeing JDK is 19, 20, 25. Okay, so whatever it is, so click on it, go to archive, or if you want to use the latest version you can use this, but if you want to do specific version like 17 or some, okay, so something like this, so go and go to the archive section and you can get those versions. Okay, now you might be on Windows, you might be on Mac, doesn't really matter. Now we are trying to do in a Ubuntu container. For all of us, we have to download either this or this. Okay, now we have two options. Which one should I download? Okay, so in order to identify who has to download what, okay, inside the Ubuntu container, type this uname -m. This will tell you which one you have to use. So for me, it's this. So because of that, I have to go with this guy. If you are seeing x80, 86, 60, something like that, x64, something like that, then probably this is what you have to use. Okay, so copy the link, do not download, just copy the link address. Okay, and let's minimize this guy. Okay, just paste it here. Okay, just we are just taking some notes here. Okay, so this is what I'm trying to do. Oh wait, it says 17, sorry 18. I thought I was doing, oh sorry guys, I wanted to download 17. Okay, so copy this link. This is what I wanted. Sorry about that. Okay, now I have downloaded, I have the link for 17. Okay, super. So in order to download, there are utilities like a wget or curl. So if you see, unfortunately, this Ubuntu, it's a lightweight image. It does not come with all these utilities. So because to keep the size less. So whatever the utilities you need, you have to install it yourself. Okay, so we have to do that first. So for that, there is we are going to use few commands, but no worries. I had already shared the Linux commands PDF, right? You can always use that as a reference. You don't have to memorize everything, but it's kind of good to know all these commands actually. So we are going to update the package manager of Ubuntu. Okay, apt get update. So if you do this, this guy will update quickly. It won't take much time. So it's done now. Okay, now I need curl. Okay, apt get install curl. If you want multiple utilities like curl, wget, you can just do like this. Okay, now it asks for permission. Say y, so this will yes. Okay, say yes, so it will install that. Now you have curl. Okay, so what are all the commands I had entered first? So the very first thing what I did is apt get update, then apt get install curl. This is what I had given. Okay, oops, apt get. Okay, now using the curl command, if you see curl help, if you see, okay, so if you are trying to download a file, so that's what it is. So you can give output file name, so it will download the content and it will write it somewhere in your location. Okay, so you have to give this option actually. Okay, we can also use wget, but I'm intentionally doing this way. Okay, so let's copy this URL, curl, paste this URL. Okay, and I am going to give output. Okay, output, I'm going to call this Java 17, and this is how I would like to write it, and this is the file name, and I have to give the extension. Okay, so give that extension .gc, this is the extension, and this guy should download that file. This is like 177 MB, so looks like yeah, it might take like 50% complete so far. Let's wait. Again, we are intentionally doing things a little bit hard way. Okay, no worries on that. So this is how we could learn all these things actually. Okay, now I have downloaded the file. If I see, I am seeing the file. So what is the command I had entered? So curl, that I had given the URL. Okay, so this is just a note. Okay, output Java 17.gc. Okay, so download it and to keep it like this. But if you see, I have downloaded it in the root directory, which is not really a good practice. Probably I could have used some kind of work directory, but this is fine. Okay, we are trying. Okay, this is not really a Dockerfile or anything. Okay, now I have downloaded Java. It's zipped. Okay, it's kind of it's a zipped directory. Okay, we have to kind of unzip it, untar it. Okay, extract it. That's what I'm trying to say. So let's extract it. In order to extract it, there is a tar utility actually. Okay, so if you say tar help, so it has a bunch of options. You can check all these things. Okay, how to use this, all those things. This will give you, actually it has, looks like a lot of options actually. Okay, so anyway, tar, okay, minus, you have to give the options. X is for extract, V is for just to do the verbose, otherwise it will not output anything, so you can see what's going on, so using the verbose command. Then Z is for like the tar gc, kind of the compressed files, and F is for file name. What is the file name you try to extract? Okay, I'm saying that, hey, there is a Java 17 tar gc. Yeah, this is what you have to extract. That's what I'm trying to say. Okay, if you hit enter, you will be seeing all this output, right? This is why we gave the V option, the verbose option. Okay, now if I list, okay, yeah, so the JDK is 17. Okay, so this is, it's now it's extracted from this. Okay, we got this file. Okay, once you have, okay, let's put the notes right away so that we do not forget it. xvzf Java 7, oops, Java 17 tar.gc. This is what we had done. Once you have extracted, right, in order to reduce the size, you can remove this file. Okay, because it's 180 MB, right? It's unnecessary file. Let's delete this file. Okay, okay, now it's gone. Let's do this. Remove Java 17 .gc. Okay, now I have unzipped. So now if you type Java, will it know? No, it will not. Okay, so we have to do few more things actually. So go to JDK 17. Now what do you see? You see a bin directory, which is cool. Okay, go to bin directory. So now what do you see? Now here you see Java. Now if you type Java, will it work? Still it will not work. If you do Java, it will work because it's still not part of the path. Okay, so we have to set it, we have to put it in the path so that now when you say Java, it will work. Okay, so what is the current working directory? This is the directory, right? And what is the default path Ubuntu has? Echo path. This is the default path it has. So we have to set that to the, we have to append this path to the existing path. Okay, so copy this guy. Okay, export, this is the command, is something like setting an environment variable in Ubuntu. Echo path is equals, okay, path is equals existing path. Okay, whatever the existing path, I'm going to keep it like this, plus in Windows we use semicolon, right? In the Mac, the Linux, Ubuntu, Linux container, I mean Linux machines, we use semicolon. Okay, just add this guy. Oops, I thought I copied. Okay, hold on. Okay, so let me copy this guy, otherwise I have to manually type this guy. Okay, copy this, paste it. Okay, so now we are good. Okay, hit enter. Now I would like to echo one more time path. Okay, we are seeing our JDK 17, this guy. Okay, so as long as we see that, it's good. Now you can say Java. Now it understands. Okay, let's go to root directory. Okay, now does it know Java, what Java is? Okay, see, it understands. Okay, Java version. Okay, so this is what we had done. So if you know what did we do after removing Java, we only thing what we did was we set up the environment variable by doing this way. Okay, path is equals $path colon JDK 17 0.2, okay, slash bin. Okay, so this is what we had done actually. Okay, so, yep. Okay, let me do this guy. Okay, this is how it was. Okay, so now these are the steps we had followed to set up Java in a Ubuntu image. Okay, so now we have to create a Docker file for this, so that we can create an image, so that I don't have to do this every time. So I can create my own image which contains JDK 17. Okay, so let's do this now. Hey guys, in the previous lecture we were trying to install OpenJDK 17 in Ubuntu in an Ubuntu container manually. So we got the steps. Now using these steps we have to create our own Docker file, so that we can create an image out of that. Okay, so these are like commented, so no worries. Now let's create the Docker file. So now the very first thing what you have to start is Ubuntu. Okay, this is the very first thing we are going to do in a Ubuntu image, right? So now then what we did, we executed this command, right? So in order to execute command, you have to use the run option. So run apt get update. Okay, so then what is the next command you executed? Run apt get install curl. Okay, okay, we do not have a work directory. You know what, let's create a work directory. Okay, work directory. So can we call this Java? We can call this Java. Okay, let's keep it like this. So whatever things are going to happen, everything will be happening inside the work directory now. Okay, so curl, oops, sorry. Okay, next command what we did was we downloaded the file. Okay, run curl. Now you need this URL. Let's copy this URL and put it here. Okay, so output and Java 17 tar.gc. Okay, this is what we got given. Okay, now that guy will download and keep it there. What is the next step? Let's keep going. Okay, tar xbzf. This is the command we executed, 17 tar.gc. Okay, then we can remove the file. Okay, why I keep using run? These are all the commands to be executed in an Ubuntu image during the image build process. Okay, that's why I keep doing all these things. Okay, then one final step is exporting environment variable. You don't have to use run. Instead, if you remember, we have the env option. Okay, env path is equals $path, okay, colon. If you remember, this is what we had done. So you can simply do this, but this is not correct. Why? Because we have created a work directory now. So whatever it's happening is under this directory. So it has to be java slash this. Okay, so hopefully this is clear. Okay, so just quickly check everything once. This is correct or not. Looks correct to me. This is exactly what we did. Okay, there is one small issue. I'll come back to that later. Now let's create a Docker image. So now I'm back to the terminal. I'm going to build the Docker image. Okay, so Docker build -t. I'm going to call this my Java 17, whatever you want to call this. You can give some meaningful name. Okay, for me, I'm okay with this. So, and where the Docker file is in the current directory. Okay, so guys, just give the command where your Docker file is. Okay, so if you hit enter, now we take the Ubuntu image, we do the apt get update. This is for updating the package manager. It might take like 15 seconds or so, something like that. Let's wait. Looks like it takes more time, but it should be done. Okay, it's done. Okay, if you remember, we were trying to install curl. Okay, during that process, do you want to continue? It was asking something like this. We pressed yes. Then we continued, but here somebody has to press Y. Okay, somebody has to give that yes option. So what we have to do is that, so okay, sometimes we will be kind of ignoring this kind of minute details, the small details like this. Then yeah, this is what I wanted to show. So in order to give this, right, if you want to continue yes for all, you can give like this in. Okay, so okay, now let's rerun the same thing now. Okay, it's installing curl. Okay, downloading Java. Wow, it's extracting. Okay, done. That's it. Okay, now if we check Docker images, okay, my Java 17 that Docker images there. Okay, so let me clear the screen. I'm going to create a container of this -it. I'm going to do this in the interactive mode. My Java 17. Since it's we extend from Ubuntu and we do not have any command or anything like this, we can easily get the, I mean, we can get the bash shell. Okay, we do not have any entry point or anything like that. So hit enter. Now I am inside that my Ubuntu container. Okay, now see it places me under the Java directory. Now I don't want to do anything. The very first command what I would like to run is, I would like to see Java is there or not. Okay, see it knows Java. Okay, so I'm going to say Java version. Wow, this is cool. Now what about Java C? Okay, it also knows what Java C is. Okay, this is cool. Okay, so now we were able to successfully install Java in an image, and we were able to create a container of this. Now we can create multiple images like this based on your requirements. Okay, so it's not like this is how you have to create a Docker image for Java, and this is how you have to use it for your microservices, etc. Okay, so there are many Java images already which we can directly use. However, the aim of this exercise is to explore this image creation process and creating our own image, how to create our own images, how to debug. This is the idea. Okay, nothing else. Hey guys, in the previous lecture we created this Docker file and the corresponding Docker image. Now I would like to make a small change and recreate the same image actually. So if you remember, we had an add option. Okay, something called add Dockerfile command, which can directly download the file and place it. That's what we had said, if you remember. Okay, so let's try that now. Okay, again we did this intentionally to install certain things. So, okay, so just we wanted to explore all these things. Okay, however, we can get rid of all these things. Okay, and we can directly use add. Okay, add will directly download this file and place it as Java tar gc. Okay, like this. So like copy will copy the file and place it inside a image, right? Similarly, add will also copy and do this. If you give a URL, it will download and place it. Okay, so it can do both. Once you have downloaded, you have to extract it, remove all those things. Yeah, we can do this. So okay, everything looks good, same stuff. Let's save this and let's create a Docker image. Now I'm back to the terminal. Let's build the Docker image. Okay, I'm going to use the same name, my Java 17, and where the project file, the current location. Okay, dot. So now if you see, we are not doing the curl, all those things. Docker directly use the add to download the file, but we are not able to see the progress though, but it does something. Okay, and it's extracting. Okay, now the Docker image is built. That's what it says. Now let's create a container out of it. Okay, looks like it knows Java. This is cool. Okay, so Java version, it prints. Okay, so this is nice. So we could have also used directly the add command, but I was trying to do all those install, curl, all those things intentionally, just to have the feel of like how to install software, all those things. Okay. Hey guys, in this lecture, I would like to quickly show you something. Okay, so now in the last lecture we had built Docker images using two techniques. Okay, first by using install curl, the other technique, other Docker file using the add command. Okay, so now I want to go check the Docker images. If you see, I have this my Java 17 image, and you might see the none. Okay, so what is this? Who created this, and how did we get this? Okay, now if you notice, so if you look at the size, this is huge and this is slightly lesser, right? Okay, so this was our original my Java 17 Docker image when we were building using the curl command, all those things. Okay, because we were adding another utility called curl package manager, etc. Oops, looks like a mistake, copy pasted, sorry about that. Okay, so because of that, what happened was it added extra layers actually. Okay, it added extra softwares. Because of that, the size got increased. Now when we replace the Docker file with the add command, we didn't install curl, all those things. Because of that, the size is slightly less. So that's good. Okay, that's good information. We know that now. Okay, now what is this none? Okay, so if as I had mentioned earlier, this was our original my Java 17 Docker image. Now when you changed your approach, when you recreated the Docker file and recreated the image, right, what Docker does is that it takes this name and gives to this new image. Remember, this is then this no longer my Java 17. Okay, your intention is to replace this image with this image. Okay, so because of that, it unassigns the name. Because of that, it became none. Okay, so it's called dangling images, all those things. So we can get rid of this. Sometimes you might be seeing this image, so I thought of letting you know. No worries on that. So in order to remove this image, you can always use the Docker system prune the -f command. Usually the -f will not touch the images. Okay, however, if it sees a dangling image like this kind of unused, not unused, this kind of none images, it will remove those actually. Okay, so now it will be it has removed that image. If you go back, now that will not be there. Okay, hey guys, in this lecture I would like to add a quick note about this copy or add command. Okay, so far in our examples we had been seeing only a single file copy and placing the file in the image, but it's not the case always. You can, if you want, you can copy multiple files actually. For example, if you want to copy the source directory and place that directory in the image, you can do this way. Okay, so once you have built the image, if you go and check under your work directory, you should be able to see the source directory and all the files. If you want to copy the source directory and place it as a diff directory, basically this is same as this, but here in the image you will not be seeing source directory. Okay, when you spin up the container, you will be seeing as a diff directory, but whatever the files you had under source, everything will be here, okay, under diff directory. That's what it means. Here I would like to copy all the files with this extension and place the files under text directory. This directory does not have to be present. If this directory is not present, Docker will create as part of the copy command. Okay, so it will create a text directory, and whatever the files you wanted to copy, everything will be placed under this. Here in this case, I would like to copy all the text files under source from my project workspace. Okay, then I would like to place them under dest directory. Okay, so we can do things like this. Hey guys, in this lecture we are going to create a simple Java file, and we are going to Dockerize this, Dockerize that using our my Java 17 that Docker image, and we are also going to pass an environment variable to the Docker container at runtime. Okay, so that is the idea. That is what we are going to do now. So in my current structure, whatever the existing Docker file, I kind of moved into a Java install Docker file. That when I created a directory, I moved it there. Okay, so now this directory does not have any Docker file, and what I'm going to do is that first I'm going to create one .java file. Then let's Dockerize it. First, let's create our Java application first, a simple program. Okay, so I'm going to use Visual Studio Code. I don't need IntelliJ for this because it's a super simple. So okay, so what I'm going to do is that I'm going to call this public class table. Okay, so public static void main, so args, right? Okay, so what we are going to do is that I'm going to pass an input. Okay, so it could be some environment variable, so we have to check how to pass input. Okay, so assuming input is the variable name, we are going to pass it. Then let's print it for, oops guys, print line. I'm going to say received input okay, so the input could be null, right? Okay, if the input is null, we are going to return immediately. Just we are going to exit. There is nothing to do actually. Yeah, otherwise we are going to parse that, assuming it's an integer, because it might not be an integer, it might throw some exception. So let's not going to do all these things, I mean error handling. So we are going to assume that input will be correct, parse int. So now I'm going to pass the input, integer.parse int input. Now we get the value. Okay, so I'm going to use a simple for loop, integer I equals 1, I less than or equals value I plus plus, simple for loop. So I'm going to simply say system.out.printf format. Okay, so I'm going to just use some kind of a multiplication table actually to keep things simple. Okay, %d, just I'm trying to show like this. Okay, so that it will look like a table actually. %d, yeah, this is what I was trying to do. Okay, also we are using printf, so I have to add a new line here. Okay, so we need three values. Those values are basically like the first one is the I value, the second one is value, the third value is what is the I times value. Okay, something like that. Okay, so everything looks good to me since we, okay, let me check, come on, all those, sorry, semicolon, all those things. Yeah, looks like in a high level looks okay to me. Let me save this and let's quickly dockerize this. Okay, so once this is done, I'm going back to my terminal to open a Dockerfile actually. Okay, so now I have this Dockerfile. We are going to use the my Java 17 as the base image actually. My Java 17, whatever we have created so far, let's use our image as a base image because we need Java. Now this image has Java already. Okay, so now let's create our own directory. The base image comes with Java, all those things, but we can create our own directory. Okay, let's call this user, I'm going to call this user Vinod table, something like that. Okay, you can give whatever you like. Let's do something. Okay, then copy table.java because okay, this is where the table.java is also present. Okay, same location, and I'm going to call this same table.java. Do not give a different name because we have created the file with the table, so it has to match, so you know. Okay, table.java. Then we can give the command. Okay, so what we have, you cannot directly execute this because if you know it's a Java file, we have to compile this first. So use Java C to compile. Okay, then what we are going to do is that if you do this right, basically it means that once you execute this, then go to the next command, something like that. Okay, Java table. So basically compile this. Now there will be a table.class and now you can execute this. That's what it means. Okay, so let's save this and let's minimize. Let's go to the command, terminal. Okay, so now I'm going to build the Docker image and I'm going to call this my table, something like that. Okay, so and the current location, if you hit enter, wow, this is super fast because my Java 17, that is the huge image that's already here in the local. So then we have to copy table.java and that's it, nothing much in this image actually. So okay, so because of that it created very quickly. So now we can run this my table like this, and yeah, we don't need interactive mode because we had already given a command to be executed, so we can use this as an executable. Okay, so if you hit enter, okay, it says that received input is null, so basically the Java program was executed. Also, as per our implementation, the Dockerfile, we are compiling this every time and executing this. Okay, some of you might be asking, hey, why are we compiling this every time? Can we not compile once and execute it every time? Yeah, we would have done that, of course. This is again all these things we are doing intentionally. At least that's what I was trying to do. But if you want to modify this, please go ahead and modify. Okay, these are like simply we are practicing, nothing else actually. Okay, now my goal as part of this lecture is to demonstrate to pass the environment variable. That is what, okay, I wanted to do. So Docker run, how to pass the environment variable. So there is a run option. It's called the E. If you say, then you can pass the environment variable, which is input here. So if I say 3 and my table, okay, If you hit enter, wow, okay, so now it's able to understand the three options. So now it prints that values. Okay, similarly, if I say 5, does it execute? Yeah, it executes. Okay, so yeah, so this is exactly what I wanted to show. Again, some of you might be asking, like, what if I have multiple environment variables? So no worries on that. You can just keep going like as we do the port mapping. Okay, like A is equal to B, E, C is equal to D. Okay, so if you have multiple environment variables like this, you can just keep going like this. Okay, so yeah. Hey guys, in this lecture, I would like to share one important information, the difference between the shell form and the exec form. When we were writing Dockerfile, we were using the command cmd or entry point for the process to be invoked, right? Okay, so it accepts the command to be executed or the process to be executed in two forms. Okay, one is called the shell form, the other one is called the exec form. For example, if you want to read the hello world text file, this is what we were using. This is called the shell form. If you want to convert that to an execute form, you have to pass them as a list of string. Okay, probably you might like this. This is easy, so why should I be doing this way? Okay, you might be thinking like this, but there are some differences between these two. Sometimes you might prefer this approach as well. Okay, so there are some limitations in this approach. Okay, so the idea of this lecture is to understand the difference between these two and when to use what, something like that. Okay, so that is what this is about. To understand the difference better, I would like to spin up an Ubuntu container first. Okay, now let's type ps. ps is a command which will print the list of processes currently running. Okay, if I hit enter, it says that, hey, there is a bash, it's running, and there is a ps process that is also running. Basically, the ps will print its own process because at the time of its printing, it was also running, right? So because of that, it will be printing its own process. Now I'm going to sleep for 5 seconds as a background process in the background mode. Okay, ampersand, which will kind of put the process, run the process in the background mode. I hit enter. Now I type ps. Now if you see, there is a bash, there is a ps, there is also a sleep running. That's what it says. If I hit ps, okay, now it's done, right? The ps is done. If I hit ps one more time, it says that now bash and ps, we have only these two. Okay, so that's what it says. Okay, so now so far how the ps command works, you understand, right? Okay, this is just a basic information. Okay, so now with that knowledge, with this knowledge, now let's try to understand the difference between the exec form and the shell form. Okay, now let's exit and let's create a Docker file. I'm going to use Visual Studio Code as usual. So open a text file or create a Docker file and let's type this from Ubuntu. Okay, cmd ps. This is what I'm going to do. Okay, nothing else. Okay, you just saw what the ps command does. So let's minimize this. I'm going to say docker run, docker, not docker run, docker build -t. I'm going to call this test. Okay, so it doesn't really matter. Let's call this test. The image name is test dot. Okay, so this is done. Okay, docker run test. Now if you see, you are seeing two processes. Okay, run one more time. You are seeing two processes here, okay, as part of the ps command which is executed inside the container. So what it basically means that when you use the shell form, which is what we just did, okay, when you use the shell form, whatever the command or entry point, whatever you are giving, right, that will be executed as a child process. That is, you will be getting a shell. That shell will be executing whatever the command you are giving. Because of that, you will be seeing two processes. Okay, so this is executed as a child process of this. So because of that, you would be seeing two processes. Okay, now let's go to our Docker file and let's change that to exec form. Okay, which is going to be a list of string like this. Okay, okay, let's minimize this. Let's build this and let's run this. Now if you see here, you see only one process, because here we are not creating a new shell to execute this. Here the PS is directly runs as a main process inside the container, so one less process for you. Okay, so because of that, the exec form is preferred. Okay, however, there is a trick, that is, we have to understand the limitations of that as well. Okay, so let me clear the screen. Let me go back to the Docker file one more time. Okay, so now this is my Docker file. Okay, I'm going to print this echo $path. That is, when the container starts, what is your environment variable for the path? Can you print it? That is what we are saying. Echo will print it. Okay, so let me save this and minimize this. Whenever we change the Docker file, we have to build it. Remember that. Okay, so build it and run this. Now it says that, hey, this is what the path has. Okay, so it clearly prints this, which is nice. Okay, so now let's go back to Docker file one more time. Now let's change that to exec form. Okay, it was shell form. Now I'm going to change that to exec form. Okay, so whatever you want to give, you have to give this as a list of string. Hey, there was a space, right? So should I be giving us a space as well here? No, you don't have to give that. Okay, it will be taken care, so no worries. So minimize this, build it and run this. If you see, it will be directly printing $path. Okay, it will not print this. Okay, so this is the difference between the shell form and the exec form. Why is it? Because it's a variable. Okay, for example, if I say pwd and all, right, when we say like this, how do you get the value of this? Because your shell, that is what interprets this and gives you the current directory, present working directory information for me. Okay, so this is what happens in Windows, Mac, Linux, all these machine. Okay, but here, since you are in the exec form, since you are not given a shell, okay, so it cannot interpret the value of the $path. Because of that, it will directly print the value as a $path as it is. Okay, so there is a limitation of this for that in that approach as well. Okay, so whichever form you like, you can use, even though they say that exec form is preferred because of the one less process inside the container. If you want to kind of use certain variables, if you want to interpret this $path, this kind of thing as part of the command to be executed, then you can go use the shell form. Okay, hey guys, in this lecture I would like to quickly tell you how Docker builds the image. Let's imagine we have one GitHub project or something like this, Bitbucket, whatever it is, your version control system, and your master branch is almost like 1 GB. Let's assume so. Okay, so we have some hash one. Okay, the corresponding version. Let's say there will be some version. Now you create a branch and you make a very small change. Okay, so now when you make the small change, when you merge it, right, so it will be kind of creating another hash for it, right? Also, when you create a branch, we are not creating 1 GB of that new branch. Even though it will kind of look like that, it kind of tracks only the delta part, right? What are all the changes you are doing actually. So then you merge it. So we kind of, again, we bring the delta and we find the new hash 2. So hash 2 is based on hash 1 plus the delta. on this hash, when you apply this delta, what is the hash? Okay, so that's how we calculate, find it, right, in a high level. Okay, so if you understand this Docker image build process, more or less same actually. Okay, so what Docker does is that, let's imagine that we have one Docker file like this. This Docker file might not make any sense, okay, but don't worry about all those things. Just but this is a valid Docker file anyway. So we take an Ubuntu image, we have one work directory, we create another directory called hello, we copy some file, we assume that there is a file in the project, we just copy it, and we run apt get update install curl. That's what we do. Okay, this, it's a valid file, and but what we are trying to do as part of this might not make sense. That's okay. So what it will do is that Docker will, this is how the Docker will build the image. That is, oh, you want to Ubuntu? Okay, let me take the Ubuntu image. Oh, okay, on top of that I have to apply this. So it will be adding each and everything as a layer, one layer on top of that. Okay, that is, there will be a hash for this, and it will be adding this layer, and it will have a new hash. Okay, then after that it will be adding another layer, and it will be having a new hash. Okay, so it will be adding a list of layer on top. Okay, on top of each and everything, something like this, layer after layer, something like that. That's how it builds the Docker image. Okay, so Docker image, nothing but a list of layers. Okay, list of hashes or list of layers, you can imagine like that, again in a high level. Okay, so what will happen is, let's imagine that this is your Docker file. Okay, so now you build one Docker image like this. Okay, this is file 1. Suddenly, as part of your project work, you have to change a small correction in the Docker file. Okay, so what will happen is, now it will try to rebuild the image. Oh, I have to take the Ubuntu, there is no change in Ubuntu, so I am going to keep the layer as it is. Oh, here there is no change, I am going to keep the layer as it is. So it will keep all these layers as it is. It will not do anything, because it will reuse all these layers, since these layers we do not have any change in these layers. Since the file got changed, okay, the file 1.txt, now it's in a version 2, there is a small change in it. What it will do is that only this layer will change now. Okay, since this layer changes, its hash will change, right? Since the hash changes, Docker, okay, so then this hash will no longer be valid beyond this point. That is, so it will build this layer, on top of that then it has to rebuild this layer, then again it has to rebuild this layer. You are getting the point, right? This is the first time it was building the Docker image. Now when you make a small change, when you are trying to rebuild the Docker image, these layers have no change. Now the file got changed, because of that this layer got changed, because of that the hash got changed. So all other layers will also be changed, because it depends on the previous layer hash actually. Okay, that's how they are all built. So the good practice in general, right, in general what we could do is, we can check where the frequently changing layer could be. Okay, so if you think that, oh, this is the layer in my project, it might be frequently changing, and run get update install curl, yeah, I will always want to have it, something like that. Maybe you could kind of make them bring them to the top in the Docker image. Okay, and move this thing down, so that when you build a Docker image, first you build a Docker image, next time when you build it, right, only this layer will change now. Okay, so the change is very small. Okay, so now when you build a Docker image, you might not be seeing a lot of difference. Things looks like super fast nowadays. Initially it was not like that. A Docker image build process, it used to take a decent amount of time. Now the build process actually, it has got decently improved now. So maybe you do not notice, but this is one of the best practice, okay, which I used to follow actually to improve the build process actually. Okay, so again, this is up to you, but for me this information is good to know. Okay, so but you can always rearrange this so that you can reuse the existing layers of the Docker image. Again, Docker image, nothing but a list of layers actually. Okay. Hey guys, let's quickly test the Docker image build process. Okay, how it works, whatever the theory, whatever we had discussed. Okay, so what I am taking the exact the Docker file which I was showing. So Ubuntu, I'm creating some work directory, hello, some copying file, apt-get update, I'm installing curl. Okay, so and this is the file. This is the first test we are going to do. That let's assume that this is v1. Okay, we are trying to do with this setup. This is the Docker file, and I'm going to show you that how it works. Okay, so I'm going to say that docker build -t. Actually I'm in the location where these two files are present. Okay, so let's say test1, let's keep it like that, dot. If you hit enter, if you see, it added the file. Now it's trying to apt-get update. Now it's installing curl. Okay, so it took decent amount of time, you saw. Okay, because if you see, it created this directory, created this directory, this layer, everything. Okay, and yeah, if you see, this is cached because, oh, you want Ubuntu I already have. Okay, so it, because we already have Ubuntu in our list here, so in the Docker images we already have Ubuntu here, so because of that it reused. Okay, so Ubuntu, it reused, it's cached. Everything else it has to rebuild, everything else it has to build for the first time. Okay, so this is how it works. Now I'm changing it to v2, test1 v2. Okay, now the file got changed, right? Okay, so now let's rebuild the exact image. If you see, now it's again doing the get update, as you see, installing curl. Okay, if you see, it took, okay, it already has the Ubuntu. Okay, it doesn't have to touch anything, and it's these layers are, they are all kind of cached. Okay, because this layer not changed. Now this file version got changed, so it has to do the copy. Because of that, it also has to do all these things. Okay, now you saw that it took some time. Okay, let's change it to v3. Again, let's do this. You can clearly see every time the file gets changed, it has to do the apt-get update and install curl. Okay, it kind of fast, but still it has to do all these things every time. Okay, now what I'm going to do is that I'm going to bring this, rearrange this, okay, like this. Now I'm going to save this Docker file. Now we are going to do test2 v1. Okay, again the Docker file, it has we have completely changed the Docker file, so because of that, the first time it has to build the Docker image. Okay, so let me clean this up. This is the test2 first time. Okay, so yeah, let's be patient, let it build. Okay, so now we have built the Docker image for the first time using the new Docker file, right? Okay, now I'm changing this to v2. The file alone got changed now. Okay, let's run this. If you see, super fast. It's mainly because this is cached, this is cached, this is cached. Only this layer got changed. Okay, now I'm going to change to v3. If I run this, again, super fast, because only this layer got changed. Okay, so you can always rearrange the Docker file. Okay, hey guys, in this lecture let's see how to create an account in Docker Hub and how we can share Docker images. Okay, so please go to hub.docker.com. okay, hub.docker.com. then you just give one username, whatever you like. Okay, so I had given like Vince Docker or something like that, so you can give whatever account you like. Okay, name and your email address, password, that's it. And yeah, sign up. It's free, so yeah, that's it, super simple. Okay, so I'm going to sign in. So you always sign in using your account name actually. Okay, so once you have signed in, you will be seeing list of repositories if you have, but if you do not have any repository, probably that could be empty. I'm not really sure how the empty page will look like. Okay, but yeah, you will see. So once you have created an account, right, this is the important step. Okay, to push Docker images, to share Docker images with others, etc. Again, this is for your personal use or you to play with the Docker, etc. But if you are really working for an organization, and if you want to do this for your project as part of your project work, probably if you are on the cloud, maybe you can use AWS ECR. Okay, so you can push Docker images. Okay, something like that. So there are also many options like that. Here, whatever the images I push, right, it's public. People can anybody can download. But for example, in the Wins Docker util, if you remember, we were playing with this. So this is the image, right? So I can push so that you all can pull the Docker image. You can also create private repositories in Docker Hub. If you go here, right, so you can also create private repositories, but I feel like it's not free, I guess. But yeah, there are also options actually to create private repositories, so that only you can push, only you can pull those Docker images actually. Okay, so once you have created the account, I'm going to minimize this. Okay, so once you have created a Docker image, and if once you have the Docker account, everything, let's look for our image actually. So if you see, I'm seeing a lot of none images. That's mainly because we were trying to rebuild the image. Okay, multiple images, the same name. So let me clean this up. Okay, so if I go to Docker images, let's imagine that I would like to push the my table, whatever we were building, right? The my table. If I have to push it, let's see what I have to do. If I say Docker push my table, it will not work, but let's start from here. Okay, it will say that it's preparing, but denied because Docker library, that is not our account. Okay, so this is you do not own this account, I do not own this account, so we cannot push it here. Okay, so we have to change the name of this image. So what we have to do is Docker build, or we can also say Docker tag. Okay, so my table. Okay, I was about to build with the new name, but we can also do this way. That is, if you have an existing image, if you want to change the name, you can do this way. Docker tag my table. Okay, and I would like to change this to Wins Docker my table. Okay, if you do this, now if you say Docker images, now you will be seeing Wins Docker my table. Okay, and if you see, the cool thing is my table is also there, Wins Docker my table is also there. Look at the image ID, the hash, it's exactly same. Okay, so it's more of a branch from the master branch, you are getting, right? Something like that. We are kind of creating another Docker image itself. Since it's simply an alias, Docker will try to reuse all these image ID layers, everything. Okay, so now we have this created this Docker image. We can also by using tag, you can change the name of the image. Okay, now let me push it. Wins Docker my table. Okay, now again it will fail. Why? Because now this account, I own this. Yes, docker.io, that is where I would like to push. Wins Docker is my account, and this is my image, so I should be able to push it. But why it's failing? It's failing because I have not logged in. Okay, so if we can push it, right, anybody can push it like this. So how do I ensure that only I can push it? So I have to log in. For that, I have to say Docker login. Okay, so if I say Docker login, so what is your username? So I have to say this is my username. Okay, what is your password? So type your password. Okay. Okay, now it says that login succeeded. Okay, now I can try to push it. Now if you see, it's pushing, it's able to push the Docker image. Okay. Okay, so now the push is complete. Okay, it took some time because the size is huge, it's able to push. So if you go to Docker Hub, if you go to repositories, if you refresh maybe, okay, so the my table is the image, it's available now. Okay, so now anybody can pull the Docker image actually. Okay, so by default it's latest. Okay, that's what we had said, right? If you had not given anything, so when you tag it, so if you do not provide the tag, it's by default it's the latest. But if you want to add some specific tag, we can always say, for example, my table, I would like to change that to Wins Docker my table. I would like to call this as a v1. Okay, you can change it like that. Okay, so now if you see, there is a Wins Docker my table latest, a v1, but they are all using the same hash id. Okay, it's not like we have to always tag that way. We can also use the build command as well. That is, when you say docker build -t, okay, now here normally we give the image name, right? You can also give it like this, Wins Docker, for example, my table, something like that. Okay, colon v4. Let's say, imagine that you are trying to build the v4 of your the microservice or something like that. Okay, so where is my Docker file? The current location. So you can also give directly like this, so that you can, once the Docker image is built, you can simply push it. Here, I mean, everything was cached, because of that it's super fast. But if you see, it's naming to Wins Docker everything with the, instead of latest, it gives some specific version as well, so that I can directly push it. Okay, so you can go for either tagging approach, or during the build up process itself you can give the account version, all these things correctly. Okay, hey guys, in this lecture we are going to quickly summarize whatever we had discussed in this section. We had to spend a good amount of time in learning Docker. Okay, so what is Docker? Docker is an open source platform for packaging the application along with all the dependencies, including the runtime. That is, if you are going to run a Java application, you will not only be adding all the jar file, all the dependencies like that, you will also be adding the JDK or JRE, whatever you need to run that application. Okay, so we package everything, including all the dependencies and the runtime. Then also, the Docker is also for running the Dockerized applications. Of course, it separates the application from the underlying host. Once an application is Dockerized, once you have created the Docker image, it doesn't matter whether you are on a Mac or Windows or a Linux machine. As long as you have Docker installed, you should be able to run the Docker image. You should be able to create a container out of it. Okay, so even if you're running on a Mac, end of the day, if you say from Ubuntu, then it will behave like it's running on a Ubuntu VM, lightweight virtual machine. That's how it will behave. Okay, so it will that's how it separates the application from the underlying host. There are some Docker terminologies. Dockerfile, of course, it's a human readable file where you provide all the instructions to package the application. Build is the process to create an image. By reading the Docker file, it will create the Docker image. Image is nothing but a lightweight virtual machine. It's a snapshot. It's not running. You have created an image. You have created a snapshot, but it's not running actually. You're getting right. The running instance of the image is container. Okay, so then Then tag is basically for versioning, adding this latest or v1 v2. If you want to add any version, you can, this is that's called tag. Okay. Then Docker Hub is something like a Maven registry, okay, Maven repository. So it's a registry through which you can share your Docker images actually. Okay. So Docker image, it's nothing but a list of layers. We had seen that. So Docker image name, this is how it will be. So image name, this is mandatory, but these are like optional fields. So for any public image like Nginx, all those things, you can ignore all those things because you can get all those Docker images from the Docker registry. So you should be able to, using this, you should be able to pull it. But for your projects, whatever you are going to build as part of your work, so for those things you might want to you will be definitely, you will be having some kind of an account, the tag. Maybe if you are using some ECR, then you have to add the registry information, etc., to push pull. Okay. Docker run, it's a command used to create a container of an image. So you can simply say docker run ubuntu, it will create a container. Okay. So there are many options we had discussed. So -d is for running a container in the background mode. -it, it's for interactive mode. Okay, and using -v option, we can, containers are by default stateless. They are like use and throw. Okay, but if you want to make it stateful, then you can use -v option to provide some files to the container or to get the files from the container, something like that. You can do volume mapping. There are also, we can also do like read only mapping, and just one file alone you can share. We had discussed that. Then using port mapping, you should be able to access the container, the process, whatever it's exposing. By using the port mapping, you should be able to access via your browser, or you should be able to access in your machine. Otherwise, by default, it's exposed only within that container. Okay, so any other container running in the network can access it, but you cannot access it in your machine. So you have to do port mapping. Then we have the -e option to pass the environment variable. If you want to give some name for your container, you can use --name option. If you want to place the container in your custom bridge network, you can have to use -network, the network name. Okay. Execute command also we had discussed. Execute is same like run, but the only difference is the run command, it will create a new container. Exec command will run this, that whatever the command you are giving here, it will be running on the, in this, whatever the existing container, whatever the name you are giving here. Okay. The -it, it's for interactive mode. If you do not want to do this in the interactive mode, you can always remove this. Okay, it's not like it's a mandatory thing. Actually, it's not mandatory. Then we had discussed the Docker start, stop, kill command. Okay, if you want to stop a Docker container, you can say Docker stop. If you want to kill, you can say Docker kill. Give the container name. Okay, and we also discussed Docker pull, to pull the images from the Docker registry. If you say Docker run, but implicitly, indirectly, it will kind of pull, behind the scenes it will pull. And we also discussed Docker push, to push the Docker image to a Docker registry if you want. You might have to log in in order to do that. So if you say Docker login, then it will ask you to enter username, password. There are also options like, for example, --username. You can give the username and a password directly in one single line. That you can do that way as well. Okay. You can Docker logout. I didn't demo that, but you can do this. This is super simple. Okay. Just Docker logout. That's it. It will kill the session actually. Okay. Then we created custom bridge network, Docker network create command. Okay, using that we create a custom bridge network, because by the default bridge network does not have the name resolver actually, right? So, but using the custom bridge network, one container can talk to another container just by using its name. Then we discussed Dockerfile. So Dockerfile is a simple text file in which you provide all the instructions. These are like, there are actually many commands, but these basic commands, these are like more than enough for our most of our use cases. From is like on what is the base image. Then add, copy. You can use either of these to copy the project file into the image. Okay. So always try to copy from your project, from your workspace. Okay, do not try to copy everything from a root directory, this kind of stuff. Normally we don't do that actually. Okay, that's a bad practice. It might not even work actually. So then run command, Dockerfile run command is for running a command. For example, run make directory if you are install curl. So the command to be executed inside the image during the build process. Work directory is to create some workspace for you. Okay, when the container starts, something like that. Expose to expose ports. Environment variable key value pair to set the environment variables inside the container. And the command or entry point, you can give what is the command to be executed when the container starts. Okay, so this is the most important step. Okay, you can use either of these. Okay, then Docker build. Once you have the Docker file created, how will you create an image using the Docker file? So this is where these commands come into picture. So Docker build -t. So how are you planning to name or tag your image? So you can give like this, the Docker util, you can directly give like this, and where the Docker file is present, the context, current directory is put dot. Okay, if you're working on a current directory, just put dot. Okay, so Docker tag, for example, maybe you have already created a Docker image and named this like a util. Now you do not have to rebuild to change the name. Okay, if you want to create an alias, just do using tag command, give the old name and give the new name. So it will be creating an alias. Okay, so something like that. So this is what it does, so that you can use this to push your Docker image. Hey guys, this section will be more fun and interesting. We are going to talk about Docker Compose. So what is Docker Compose? We had spent a good amount of time in learning Docker. We had used many imperative commands like docker pull, run, with volume mapping, port mapping, passing environment variables, etc. There are many commands and options to remember. Docker Compose is an utility to do the same thing in a declarative way. How we would like to create containers, what are all the images we need, what are all the path to map as part of volume mapping, what are all the ports we have to map, etc. You provide all these information in a simple YAML file. Okay, like this. This is the file format. So you will be giving everything in a YAML file like this. Not everything is mandatory, so no worries. Just imagine, I need to create a container of a Docker image, okay, by passing 2 environment variables, 2 volume mappings, 2 port mappings. Okay, I cannot do this on a daily basis, right? So instead, I can create a simple configuration file, a YAML file like this. It's very nice and clean, easy to read. So Docker Compose is a tool which will read this config, a YAML file, and it will be creating containers as I have given here. Okay, so this is the file format which we can use this as a reference. Okay, so let's not waste any more time. Let's get started. Hey guys, in this lecture we are going to play with Docker Compose. So under Docker Playground, I have created one directory, section 02 Docker Compose, something like that. It's an empty directory. So here we are going to do some exercise. Okay, so we are going to play with the Docker Compose. So yeah, okay, so now I'm going to open this here. Okay, I'm going to use Visual Studio Code. So basically I need a text pad to create the YAML file. So this is the directory under which I'm going to create one empty directory. I'm going to call this lecture 01 simple nginx. Okay, this is how I'm going to call this. Okay, and under this I'm creating a directory. So under this I'm going to create a new file actually. Okay, this file is going to be called docker compose YAML file. Okay, so this is how the structure is currently I'm keeping. Okay, so now you can use you had seen that the file format, right? So the very first thing will be version. Here I'm going to say 3.0. okay, version 3. So what is this version? So the whatever the YAML file you are providing, right? So that is called compose file, docker compose file. It has a specification. This is the specification version actually. So currently we are in the major version 3. So there are also minor version like 3.8, 3.9, etc. But you can use the major version 3. Okay. So when you read about Docker Compose in the internet, probably there will be many blogs. They are still referring to version 2. That will also work, but there are many things got deprecated, so it's better if we stick with the 3 version. Okay, so this is what I'm going to use in this course anyway. Okay, so now then services, these are like you have to give these two is mandatory actually. So what is services? Services is nothing but a list of applications you are going to have. Okay, so the services, it's basically contains the list of applications you are going to define here. Okay, so it's an object under which you are going to provide various applications. So applications are nothing but the containers you are going to run. Okay, you have to provide the configuration, how you are planning to what are all the run options, what are all the value mapping, port mapping, you have to define everything. Okay, so you have to give a name for your application or service. So you can call this engine X. I'm going to run engine X, or you can simply say my web app. Okay, you can also say like that. Okay, you can give any name you like. So I'm saying instead of calling engine X, probably it will be confusing, so I'm going to call this web app, something like that. Okay, so now remember that the YAML file, it will be causing a lot of confusion. You have to be very you have to be extra careful on the space you are giving here. Okay, so you have to be very careful. In the web app, it's not here. Okay, I enter a tab. Okay, so like this. Okay, now web app, under which this is an object under which you have to define all this configuration. So I am entering another tab. Okay, so services contains application will contain the configuration. Okay, remember that. Okay, so now what is the image you are planning to use? Okay, this application, which Docker image it uses. Here you have to say nginx. Okay, nginx is the Docker image. Okay, so what else you need to run this application? Actually, this is more than enough. This will work, but in our case we also need port mapping. Okay, so you have to say ports, then you have to define the list of ports actually. So this basically means that arrays, okay, these are like object fields, object properties. This is a list of property. Okay, list of string, list of numbers, etc. So in our case, we would like to map port 80, host to port 80 with container port 80. Okay, so usually for the numbers, right, numbers with the colon, so the YAML file sometimes they interpret it differently. So because of that, it's better to use it as a string actually. Okay, so like this. Otherwise YAML, the parser, they will kind of treat it differently. Okay, so that's why. So now hopefully this is clear what we are doing. Okay, maybe in future instead of calling this image, in case Docker Compose changes its name to Docker image, something like that. Okay, so what they will do is that they change the specification, they call this as a 4, something like that. Okay, so as part of the 3 specification, this is called image. So that's what I'm saying, it's an example. Okay, so let's save this file. Okay, so now this is the structure I have. You're getting right? Okay, so now I minimize this. So back to the terminal. Now if you see, I can you should be able to, I'm in this directory where I can see this, the lecture 01 simple nginx directory. I can go inside the directory. Now if I list, I should be able to see the docker compose YAML file. So this is where I am in the path, okay, in the terminal. Okay, so before running the docker compose command, I would like to get rid of all the images I have. So docker system prune -af, let's delete everything. Okay, let's clean this up. Okay, now I do not have anything. So this is where I have the docker compose file. What I would like you to do, this is the command you have to enter, docker -compose. Okay, it's not like a docker space, docker -compose, then space up. That's it. Okay, nothing else. Hit enter. This guy will automatically pull the docker images, everything for you as usual if it is not there, and it has started the process, if you see. Okay, so what, based on the configuration you have provided in, based on the configuration in the YAML file, it has started the container. Now let's go to your favorite browser. If you go to localhost, if you hit enter, you should be able to see nginx. Okay, so this is cool, right? Okay guys, in the previous lecture we were using our docker compose file to spin up the nginx container. Okay, by using docker compose up command, we were able to easily run the container most immediately. Okay, so now what I would like to do is go to another tab and let's explore few things actually. Okay, so I am still in the same directory in the another terminal. So if you remember, we had done docker system prune -af. So if you go to docker images, of course it would have pulled the nginx image we saw. Okay, if you do docker ps, if you see, it runs the nginx container. Okay, it does the port, has done the automatically done the port mapping, and if you see the name, right, by default it will be assigning a random name, but if you see, it uses lecture 01 simple nginx. Okay, so the directory name by default it will use your project name. Usually the directory is a project, that's how it assumes. So it's a project name or a directory name, then the service name, actually the name. So we had a given web app. Okay, so that is what it uses. Okay, then it says 1. So I'll come to that part later, but for the time being this is how it names. Okay, you can imagine that. Okay, I mean you can understand this. Okay, how it works. Okay, so then another cool thing is go to network, docker network, and if you say list network, if you see, this is the default bridge network we had discussed, host none, but if you see, it has created one custom bridge network for us. Okay, so again it uses the project name or the directory name, lecture 01 simple nginx. It uses that as, then puts adds _default as the network name. So this network is also available for us. Okay, if you want to use it actually, which is good. Okay, so you can, so these are the things it creates for us behind the scenes. So we can also use docker compose ps. Like docker ps, you can also use docker compose ps to see the list of services, list of applications it's running as part of the configuration file you had provided. Okay, in our case we are running only one container, and this is the port mapping we have done. Okay, so yeah, these are the, I want you to explore like this, run this command and see what's going on, everything. Okay, so that it will be helpful for you to debug later. Okay, so now let's go to this terminal. Okay, once you think that, yeah, okay, I'm done, I don't need this nginx now, if you ever think like that, you can always press Ctrl C. That's what I'm going to do in my keyboard now. So it will exit immediately. Okay, so now if you go back and if you go to docker ps, okay, it exited. Okay, the container is still there. So if you go to docker network ls, the network is also still there. Docker ps, okay, docker ps will show only the running containers, ps minus a. Now it will show that the containers are still there. Okay, so usually if you press Control C, right, so it will come out of it, it will stop the process. Now if you go and check, of course the container itself is not running, so you cannot access nginx. Okay, if you try to rerun the docker compose app, okay, so it says that it's recreated, and again it will simply start running everything. Okay, if you go back, if you say docker compose ps, again we can see that it's running. Okay, so you can again press Control C to come out of it, and like up command there is a down command. Okay, docker compose down. Okay, so if you cannot see this, I'm going to clear this screen so that you can see it here. Docker compose down. So this will be removing the resources it had created. Removed the network, removed the docker containers. Okay, so now everything back to normal. So if you go back and check docker compose ps, nothing is running. If you go to docker ps minus a, no dead containers, everything got removed. If you say docker network ls, so the custom bridge network it had created, that is also gone. Okay, so again it will, so the up command, it will bring the infrastructure up for you, you can use it. Then if you say down, everything will go down. Okay, everything will back to normal. Okay, super simple commands, easy to remember. Hey guys, in this lecture I would like to share a quick information and a simple demo. So almost most of us we always name the file or keep the name of the file as a docker compose YAML. Okay, if you go to any GitHub project, you probably have a readme file, right? You always name this as a readme. That's how we name that file, right? Like something like a best practice. So we always keep this as a docker compose.yaml, that normally you will keep it in the root directory of the project. You will be seeing that later in this course actually. So however, it's not really mandatory. So you can always have some name if you like, some other name if you like. So however, the docker compose up command, it will be always looking for docker compose YAML, something like this. But if you change the name, you have to explicitly say that actually. So for example, let's I'm going to copy this and I'm going to paste it here with a different name actually. Okay, so I'm going to rename this as a, okay, rename this as a image, or you know what, let me call this nginx YAML. Okay, let's call this nginx YAML like this. Okay, same file. Okay, so now let's go back to the terminal, and I am inside, I am here where the nginx file is there. So what I have to say is that docker compose -f. Okay, what is the file name? Because hey, do not look for docker compose YAML, this is the file you have to use. So you have to say nginx YAML up. Okay, so now this will be using the nginx file to create the resources. Okay, so this is the file it uses. If you are confused, maybe since we are simply copied the file, everything looks same, maybe in the nginx YAML file change the application name, and you will be seeing different name here. Okay, so now you should be able to access nginx, etc. Yeah, you can if you want to get rid of this, just get rid of this as usual and use the down command to remove all the resources. Okay, hey guys, this lecture is going to be another quick lecture. So every time whenever you say docker compose up, so So this terminal is being occupied, right? So the nginx process is running. That's how we see, right? So in the Docker, there is you can run things in the background mode. Similarly, even in the Docker Compose provides that option. So you can say Docker Compose up -d. If you say like this, everything will be started in the background mode. So it will you will get the terminal back. So you can always say if you say localhost, you can see the nginx. Okay, so whatever we had done as part of the nginx, you can access it here. So thing up -d is for running the things in the background mode. Okay, so you can always check what it is, if it's running or not. You can always check the status. Now you can also ask for Docker Compose logs. If you say like this, you will be getting the logs, what's going on in the background mode. Okay, like Docker logs. You can also use Docker logs, that will also work. Docker logs container name, that will work. You can also use Docker Compose logs to access the logging information. I used the curl command, the corresponding entry. See, you see it here actually, right? Okay, so Docker Compose logs, it also works like this. Okay, so now things are running. Now I can use down command just to kill everything. Okay, now everything is gone, everything stopped. So now if I go back and if I say curl localhost, hey, what are you talking about? Nothing is running there. So that's what it shows. Yes. Okay. Hey guys, in this lecture, let's play with the nginx again by doing volume mapping via Docker Compose YAML file. Okay, so for that, I'm going to create a separate directory. So let me create a new directory. Let me call this, oops, I thought, okay, oh yeah, okay, lecture 02 nginx volume. Let's nginx volume. Okay, like this. Okay, so I'm going to copy this file and paste it here. We can reuse the same file here. Okay, so same this file, and here what I'm going to do is that I'm going to add values. Okay, so now here I can map a list of host path with the container path. Okay, it's an array. Okay, like a port is an array. Similarly, you can add multiple directories mapping if you want. Okay, so if you see, they are all in the same level. Okay, remember that. Be extra careful with this this YAML. Okay, so under this guy, I'm going to create one new directory. I'm going to call this data. Normally this is how I will keep, but it's up to you. The name can be anything actually. Okay, I will not keep everything here. It will be super confusing. So I will be having Docker Compose YAML file, and I structure multiple directories, keep things in the data directory for the volume mapping. Okay, so under that I am going to create a new file called index.html. Maybe, yeah, this is what we are going to do. So index.html. Now you see the structure how I am keeping, right? Okay. So here, as usual, I'm going to have one h1 tag, and I'm going to say Docker Compose is awesome. Okay, I'm going to say like this. That's it. Super simple. Nothing else. I'm saving this file. I have saved this file. Okay. So now let's come back to Docker Compose YAML file. Here, what I'm saying is that I'm going to say list of the list of volume mappings. This is what we are going to do here. In the current directory, that's what I'm saying, dot, in the current directory, dot slash, there is a data directory, right? In the current place, there is a data directory. Okay, I would like to map this with a container path, which is, if you remember, if you had forgotten, it's called, it's user share nginx html. Okay, so this is where the path is. Okay, so the data directory, I would like to map the host data directory with the container this path, like to map like this. Okay, if you want to do read only mapping, you can add RO like this. It's a read only mapping. Or if you want to map only the index.html, you can say index.html. the only file. If you remember, we can also do just the file alone. You can also do this way. Okay, so let me keep it like this for now, but you can play with all these options actually. So let me save this. Okay, so now let's go back to terminal. In the terminal, ensure that you are in the place where you can see the data, Docker Compose, YAML, everything, your lecture 0 to Nginx volume directory. That's where I am. I can simply say Docker Compose up -d. Let's run things in the background mode. Now things started. I can simply say curl localhost to access our index.html. Wow, if you see, Docker Compose is awesome. Our Nginx is serving. Okay, so now you can also open the browser and go to localhost and hit enter. Docker Compose is awesome, right? This is cool. Hey guys, in this lecture we are going to do something cool with the Docker Compose actually. Okay, so I'm going to create another directory and I'm going to call this lecture 03 compose network. Okay, something like that. Okay, so here I'm going to copy the Docker Compose YAML file, copy this from the first lecture. Okay, I'm going to paste it here. Okay, so let's come here, and if you remember, as I had mentioned earlier, so we can have multiple applications here. So far we have one web application, so why can we not have another application, so which is our util application. If you remember the Wins Docker util application, I'm going to call this util. So whatever you want to call this, we can call this actually. Okay, now I'm going to say what is the image name. So it's called Wins Docker util, right? The image name. If you say latest 6 version, or if you want to say 3.5, we can give like this. Okay, so in our case it's just Wins Docker util, nothing else. The name, it's the latest tag by default. Okay, so then if you remember what we were using, we were running Nginx container. First we created a network, then we created Nginx container using the network, then we created this container in the same network, then we were trying to ping. Okay, so we were doing a lot of things to make one service to talk to another service. Now you can see how fast it will be happening, everything via Docker Compose actually. Okay, in our case this util does not have any port mapping or anything. Okay, so we want to run a command when this container starts. So that command is simply calling this service. That's it, nothing else. Okay, so command, this is the command. Okay, I would like to provide, there is a command option. Okay, you can give like this. What is the command you like to run? You like to execute when the container starts. I would like to execute curl command. Okay, so how are you going to call the service? What is the service? Okay, the service name is this. This is the service name. Okay, so one container can talk to another container just by using the application name or service name. So in this case it's web app. Okay, remember you cannot say Nginx. Okay, because Nginx the image name. So whatever the name you have here, this is what we have to use. This is the service name or application name. So in this case we have to use web app. Okay, you can also say HTTP web app, something like this, because that is the service name here actually. Okay, so this is what I would like to do. So let's save this and let's test it via terminal. So I'm back to the terminal. Ensure that you are in the Compose network. Okay, so that location actually. So now I am going to type Docker Compose up. Okay, so if you hit enter, okay, the util image is missing, so because of that it's trying to download everything. Now if you see failed to connect to web app port 80 after 5 millisecond, connection refused. Okay, so that is, this container started first before this container starts. Okay, so there is a problem here actually. Okay, so it kind of created two containers. However, this network util cannot or unable to do the curl because this application was not even there, nothing was running on port 80. So because of that it exited. Okay, so only this container, only one container is running. So if you go to another terminal and if you try to check, so probably will be saying that only one is running, the another one exited with error code. So there is a problem here. So let's try to fix it. Let's stop this and let's go back to our Docker Compose YAML file. Okay, so go here. What we are going to do is that there is an option here, that is we can say depends on. Okay, add like this, depends on, it's an array, you have to say web app. Okay, save this, that is Docker Compose might start the containers in any order. Okay, so because of that, sometimes this guy started first even before this guy started, and because of that this guy was not able to call this guy. Now when you add this depends on, oh, Docker will assume that, oh, this is how he wants to start. Since this guy depends on this guy, let me start this guy first, then let me start this first, second. Okay, that's how this will do. Okay, so let me minimize this. I have saved. Okay, so after making this change, save this, minimize this, let's clear this. I'm going to do Docker Compose down to get rid of all the resources it had created. Let's again start from the scratch one more time. Docker Compose up. If you see, now Nginx started first. Now if you see, you are seeing the home page. Okay, this is super cool, right? Everything happens just like that in a second. Last time when we were trying to do this, we had to create network, placing the containers in the network, we had to do all these things. Now everything is happening in a second. So when you say Docker Compose up, everything comes up and running. Now you can simply just kill this, that's it, everything is down now. Okay, the whole setup is gone. Now if you want, once again, just do and Docker Compose up, that's it, you are seeing the home page. If you say down, everything will be gone. This is super cool, right? So how it works, as you know, when we use Docker Compose, by default it creates a network for the project. Okay, with using the directory name, it creates a network and it places all the containers in that network. So the name resolver will work, so one container can talk to another container in the Docker Compose YAML file super easily. Okay, so let me kill this and I would like to show one more thing with that, with the file. Okay, so let's open the file one more time. Now I'm going to remove the ports mapping, because normally you need the port mapping only if you want to access things via your browser. If the containers are going to talk among themselves, you don't need port mapping, because this guy can talk to this guy. Okay, so this port is always exposed, we had already discussed that. Okay, for the network. So let's minimize this and let's issue the Docker Compose up. Okay, let me issue the down first and issue up. If you see, it still works fine. Okay, hey guys, in this lecture we are going to see passing environment variables via Docker Compose YAML to our Docker container. Okay, so before we go to the Docker Compose YAML, we start writing the YAML, I would like to show you something. Okay, so there is a command which will help us to access all the list of environment variables we have actually. Okay, so there is a Ubuntu command, docker run Ubuntu. If you remember, we can pass date, all those things, right? Similarly, there is a command called env, which will tell me, hey, these are the environment variables you have. So Ubuntu is a super lightweight container, and this is what it has, nothing much. Now if you go here and if you say the run option, as part of that you can pass some new environment variable, right? Right, inputs equal to 55, something like that. If you pass it like this, now env, it also contains that, shows that hey, you also have input 55, something like this. So the whatever the process which we will be running inside the container should be able to access this environment variable, system dot get environment input 50 input, that it should be able to get it. You are getting right? Okay, so why I am saying this is mainly because now this is the approach we are going to use to verify if I am getting the environment variables inside the container or not. Okay, so in my Visual Studio Code, I'm going to create another directory. So I'm going to call this lecture 04 environment variables. Okay, I'm going to keep it like that. Okay, so now let me copy this file and paste it here. We can edit it. Okay, so now I have Docker Compose YAML file. We do not need all these things. Okay, so I'm going to create an Ubuntu image. So I'm going to call this Ubuntu, but this name can be anything. Okay, this should be Ubuntu. Okay, so what is the command I'm going to run? I'm going to run env command. Okay, when the container starts, this is the command I'm going to run. Okay, now there is a property called environment. Okay, using this property you can pass the list of environment variables you want to pass to the container. Actually, I can simply say app.name is equal to product service. You can call you can pass whatever you like. Okay, the list of variables. Okay, so service.url is equals google.com. okay, also input is 56. Okay, so you can pass multiple environment variables like this. These are like simple examples. Okay, so now you can save this. Now let's go back to the terminal and let's verify this. I'm back to the terminal. Ensure that you are in the environment variables this directory. Okay, so Docker Compose up. If you see, it shows the input, app.name, service URL, everything. Okay, so whatever we have passed. Okay, so Docker Compose down, nothing is there. Docker Compose up, again it shows the whatever the environment variables it has. Here guys, in the previous lecture we were passing the environment variables like this in our to the Docker container via our Docker Compose file, but it's not like you have to always pass it like this. Okay, what if you have hundreds of properties to pass? Okay, so probably what we can do is, there is also another approach, that is I'm going to create a file under this. I'm going to call this app.env, some property files. Okay, so here also we can give a set of properties like this if you want. Let's say a1 is equals a1 val. Okay, let's keep it like that. b1 is equals b1 val. Okay, like that. So you have set of properties. Okay, so you have some properties like this. So what we can do here is we can come and add environment file. Okay, so go and read this file and pass them as environment properties to the container. We can also mention like this, whatever the file name you have, that is what you are having, passing it here. You can also have multiple property files if you like, actually. So this is nice, instead of updating 100 variables like this. Okay, so we can also remove this and you will be getting only these, but we can also have a mix of these two, this and this. Okay, let's try both actually. Okay, so let's save this file. I'm going to minimize this and I'm going to bring the my terminal. Okay, I'm in this location where you can see this file. Okay, so now I'm going to say docker compose app. Now if you see, along with the app name, service URL, input, all these things, the A1 val, B1 val, so we can also see these environment variables inside the Docker container actually. Hey guys, in the last couple of lectures, we had discussed how to pass environment variables to the Docker containers. So those were working fine. But what if my requirement is slightly different? That is, I do not have to worry about the container environment variables. Instead, I would like to have environment variables or variables for this in this Docker compose file. That is, I would like to pass an image name at runtime. It could be Ubuntu, it could be Nginx, it could be anything. Okay. So what if I want to have variables in the file itself? You are getting right. So there is also an option for it actually. So to demo that, let's create another directory. Okay, so let's call this lecture 05 compose environment variable. So let's keep it like that. Okay, and what I'm going to do is that I'm going to copy the first simple Nginx file, then I'm going to paste it under here. Okay, in this location. So now this is our Nginx file, if you remember. So here what I would like to do is, by default, yeah, this is the compose file. Now I would like to introduce one variable. Okay, so the tag, it's going to be by default use latest, but sometimes I might want to pass a specific tag. So how to do this? So what I'm going to do is that I'm going to expect an environment variable called a tag. Okay, this is the default value. Okay, so if you colon minus, if you say this, so then you are giving a default value. Okay, so by default there should be some environment variable called a tag. Try to use it, try to substitute here. If it's that variable is missing, nobody is setting anything, take this value as default. So in this case, Nginx latest, Nginx colon latest, that will be appended. If somebody passing environment variable called a tag, let's say v1 v2, Nginx colon v1, that is how it will assume. Okay, super simple. Open the terminal, go to the location where the compose file is present, for which we have to pass the environment variable. Okay, so now I'm going to simply say docker compose up -d. So everything is running. If I say curl localhost, I'm getting this. Okay, so by default I have not set, I haven't passed the tag. Okay, so everything seems to be running fine. So now I'm going to say down to bring it down, so it's working without passing anything. Now I'm going to say export tag is equals, there is a tag called Perl. If you remember, we had seen this for Nginx. So that is what I'm setting now. Okay, now if I say docker compose up, okay, before I do this, I would like to show you that Docker images, there is no Nginx Perl in my local, I have not downloaded. Okay, so I'm going to do docker compose up. Okay, up -d. If I hit enter, if you see, it's pulling the Docker image, it's not there, Perl. So it's pulling the Perl thing. Now it has started. Okay, so if I say curl localhost, yeah, I'm still seeing the home page, but this is a different image now. You're getting right. So if I go to Docker images, I should be seeing Perl as well. So this is what currently it's running. So if you want to pass a different value to the compose file itself, we can also go this route. Okay, so using this approach, you can change the version before you start the Docker compose. Okay, you can also change the ports, or you can also change the value of 56. Instead, what you can do is you can do like this. Okay, so whatever the input you are passing, that will be passed as an environment variable to the container. Okay, or you can also have it like this. By default, say send 10 if it's not set, or if somebody passes input, just give it to the container. Okay, we can also do things like this. So whatever you want to do, you can take this idea, and whatever you want to do, you can do. Okay. Hey guys, so far we have learned decent amount of Docker and Docker Compose, and we have played with all these tools enough. Now beyond this point, we would like to do something as we would want to do in the real life. So as a first thing, what I'm going to do is that I'm going to spin up the Mongo database. Okay, so go to Docker Hub and search for Mongo, and you will be landing on this page actually. So if you look for any Docker image, search for any Docker image description page, right? So they will be giving you decent amount of information actually. So what are all the environment variables you can expect, all those things they will give you actually. Okay, they will kind of explain everything. That's how I also understand and create my Docker Compose file actually. Okay, so now what we are going to do is that we are going to create one Mongo database, and we are going to have another application called a Mongo Express. Okay, this is an UI for to connect to Mongo database and see the database, create new database collections, view the records, all those things. This is basically something like a PG admin for your Postgres database. Okay, this is basically an UI for the Mongo database. So we are going to create a Docker Compose for this. So this is what we are going to do. Actually, if you go to this page, they themselves give you one Docker Compose YAML file actually, which we can directly use. However, I would like us to do it ourselves. Okay, it could be kind of a little bit exercise as well. Okay, so instead of copy pasting this, if we can do it ourselves, it's good for us actually. So it kind of expects for Mongo database, right? It expects these two environment variables. What is the default admin or root username and the password? So you can, whatever you want to have, you can pass them via these environment variables. That's what they are saying actually. Okay, so by reading this documentation, the description for each and every the Docker image, so you will get some good idea. Okay, what they expect, how to spin up all those things. So let's start with the Mongo. Then let's create Mongo Express. Let's connect everything together. Okay. I would also like to add this quick note while doing this. So if you remember, when we pass environment variables, we used to pass this as an array, right? Like a list. So here we will be giving a minus option, then you key equals value. Okay. Minus some key is equal to then value. This is how we used to pass. But here if you see, this is slightly different, right? So here if you see here they pass this as a object actually, key colon value, key colon value. So this is also correct. Okay, both you can pass the environment variables in both ways. So it's not like one is correct, the other one is wrong. Okay, so it kind of expect it kind of accepts in both format actually. So no worries on that. We can also try this way. I'm back to Visual Studio Code. So here I'm going to create a directory. I'm going to call this lecture 06 Mongo Express. Under that I'm going to create a new file, and as usual it's going to be called Docker Compose YAML. Okay, so the version, as you know, it's going to be 3.0. Okay, and here we have to create the list of services tab. Okay, so the first service I have to give some service name or application name. I'm going to call this Mongo. I can call this DB whatever I like, but still I'm going to call this Mongo. And the image is going to be Mongo. You can give a latest or whatever you like. So I'm going to use latest. Then we can do either port mapping. Here we do not have any application to connect to the Mongo database. Here we are going to spin up Mongo Express here, which will be talking to Mongo. So no port mapping required because they will be in the same network, so they can directly talk to Mongo database. Okay, and as you know, it expects environment variables. Environment. We used to pass things like this, key value. This is how we used to pass. Let's try the object approach. Okay, the key colon value approach. We can try it. Okay, so the Mongo init db. underscore root underscore username. Okay, so this is what they expect. So what is the default admin username password you like to give? That's what it says. So I'm going to call this admin, or give your name, whatever you like. And another property is password, and I'm going to call this password. Okay, so that's it. So this is our Mongo application. This is the definition for our Mongo application. In the Docker Hub, we also have Mongo Express. Okay, so search for it. You'll be landing on this page. Go to description and you can get an idea about the Mongo Express. So here they have a bunch of environment variables actually. Okay, but they also set default, so it's not like you have to pass everything. They set some default values, but you can override whatever you like to override. So remember that Mongo Express and UI for the Mongo database, right? So Mongo Express needs to know where the Mongo database is up and running. So you have to give the server details. Where is the server? What is the server port? What is the server username? And what is the server admin password? Okay, if you had set up all these things, you have to let this guy know. Otherwise, this guy cannot talk to the Mongo. So it expects all these variables. Here, there are a lot of things not applicable for us, but these information, it's applicable for us. Okay, because we have set admin username and admin password, so we have to tell Mongo Express what is our Mongo database admin, what username password. So we will be passing this. Okay, so using this information, right, we can try to create the Mongo Express the container using Docker Compose. And if you see, this guy exposes port 8081. So the UI can be accessed via port 8081. So let's go to our YAML file and add this information. Okay. So let's add the Mongo Express application. The name of the application, I'm going to keep this as Express. Okay, so the image is Mongo Express. That's how they call. Okay, and it has ports map. We have to do ports mapping for this because we want to access the UI in our host machine. Okay, so I would like to map 8081. Okay, and remember that we also need depends on, because this Express has to talk to Mongo. So Mongo has to be up and running when the Express starts, right? So let's add the depends on as well. Depends on Mongo. Here the Mongo is not the container name. Sorry, Mongo is not the image name. The Mongo is the name of the application. Remember that. Okay. And it expects a bunch of environment variable. We had seen that. So one is me Mongo Express config. Okay, me config Mongo DB admin username. Okay. Okay, me config Mongo DB admin username. Okay, super difficult to remember for me. Okay. So what is the, okay, this is what we had given. So let's copy this and paste it here. So we are telling Mongo Express that, hey, using this credential, talk to that guy. Okay. So now let's copy this and paste it. We also have to give the admin password, right? So that is password in our case. Then we also have the server, where the server is up and running. Okay, do not say localhost. Okay, most of us, actually I have seen developers by doing this. Remember that it's not localhost, because this is a Docker container. So the container has to talk to another container. So this is basically this is a different virtual machine. This is a different virtual machine actually. Okay, so this container has to talk to this container. So they talk to each other by using the name. So here the server is Mongo. And we also can pass the port, but port is defaulted to the 7017. So we don't need here. So if you see, right, this is what we need actually. Almost everything looks good to me. So now let's go back to our terminal. Let's try to do the Docker Compose up and let's see what happens. Okay. Hey guys, in the previous lecture, we had created the Docker Compose YAML for Mongo and the Express application. So now we are going to spin up these containers just by using a simple command, Docker Compose up. Okay. So ensure that you are in that location, Mongo Express location. Okay. So you should be able to see this Docker Compose YAML. Okay. So Docker Compose up and let's hit enter. Okay, so it will be pulling those Docker images. If you have not pulled those already, you know this. So it will take few more seconds maybe. Okay, so now if you see, okay, it says waiting for connections, port 27017. So everything seems to be up and running. This is super cool, right? So the Mongo and the Express, everything seems to be running actually. Okay, so now go to another terminal. Ensure that you are in the same location here. Okay, another terminal. You should be able to see your Docker Compose YAML. Okay, so now I would like you to issue this command, Docker Compose PS. Okay. Now if you see, right, it has two applications, two services. Mongo is running 27017, the port is exposed from the container. Great. But Express exited the zero status code. It exited immediately. It's not running. But in our case, both of these applications should be up and running. That's what our expectation was. But here Express exited immediately. Okay, so but here when you look at the log, everything looks nice to us. We do not see any issues, but sometimes it will be happening like this. Okay, so definitely this kind of things, it will happen in the real life as part of your project work. So we should be able to debug actually. Okay, so let's try to figure it, find the root cause. So Docker Compose logs. Okay, so I would like to access the log for that application, that service. What is the service? Express is the service. Okay, so give the Express log. Now if you see, the Express application has said welcome to Mongo Express and current service discovery also. It says something. Okay, so couldn't connect to database using connection string MongoDB admin password Mongo. So for us, if you see, right, the admin, the password, these are the credentials we had given, and the server name is Mongo, port is correct, everything looks perfect to me. Ideally using this, it should have it should be able to connect to the database. However, it couldn't. It failed because of this reason, right? It exited immediately. Okay, now if you go back to the Docker Compose, if you see, we saw something like this, waiting for connection 27017. This is when it printed this information. But if you scroll up, if you keep going up, here only it says that Mongo database init process is complete. This is when it's going to say ready for start up. Okay, if you keep going up, okay, keep going. Okay, so this is when it kind of creates this, whatever the user we had given, it kind of creates all these things. Keep going up. Okay, so now if you see, this is when the Express was trained to talk to the Mongo database. Okay, but beyond this point only, the Mongo database is itself up and running. It creates all those things. But even before the user was created, Mongo Express was trained to connect to the database using these credentials. That time the Mongo database was not even ready actually. So because of this reason, it failed. Okay, now some of you might be asking, hey, we already used the depends on, right? So why this guy was trained to talk to the Mongo database even before this started? We used the depends on, right? That's a good point. Again, keep going up. So if you keep going up, right, this is when everything started. Okay, it ensures that Mongo started first, Express started next. Okay, so Docker Compose depends on guarantees that I will be starting these services in the order you gave. Okay, if you say Express depends on Mongo, I will ensure that I start Mongo first, then Express next. That is the guarantee Docker gives. So Mongo it started, then it started Express. However, Mongo takes some time to start because it has to create these users, all these things. But Express application, right, it's super fast. Okay, so it does not have all these issues. It will just whatever the credentials you gave, using that it will try to talk to the Mongo database almost immediately. So remember that depends on guarantees the container starting. That is the guarantee it starts. For Docker, right, all these containers are completely black box. That is what is happening inside the container, the process status, it will not know, because there are millions of applications in the world. Okay, you can almost Dockerize everything. So some application, what the application does inside, Docker will not have any clue. You are getting right. So if Mongo application is super slow to start, Mongo will not, Docker will not know all these things. Hey, I started in this order, but why it fails and it's up to you. So you have to fix it them yourself. Okay, so this is our problem actually. Okay, so we have to ensure that we talk to the Mongo database only after everything is ready. Okay, so this is our problem. We have to fix this ourselves, and it depends on cannot help us here. Okay, depends on is good, but it's not always helpful. Okay, so let's fix this. So I'm back to the Visual Studio Code. Here, unfortunately, there is no delay by 10 seconds, delay by 10 minutes, and all we cannot give. However, there is an option, that is, we can say restart always. That is, what it does is that if you exit for some reason, restart this container. That is what we are saying. So our expectation is this should be up and running, this should be up and running. If this guy exits for a reason, probably this guy started soon earlier before this Mongo started. Okay, so in that case, just restart one more time, retry one more time. That is what we are saying here. Super simple fix. So now let's go back and test. So I'm back to the terminal. So let's kill this, and I'm going to do docker compose down, so clean up everything. Okay, so now let's issue docker compose up as usual and see what's going on. Okay, so if you do this, now we can see that welcome to Mongo Express server is listening. Okay, now finally it seems to be up and running. This red, don't be scared, this is not error or anything. Okay, let's come back to this later. If you scroll up, it says exited with the code 0. Okay, again if you scroll up, there will be another exited with the code 0. So it retried a few times, and finally Mongo database was up and running, so that it was able to connect. So the restart always, that seems to work. Okay, nice. So okay, so the Mongo Express is an UI application. So if you want to give some credentials for the UI application, you can give. There is an environment variable for that. Since we have not passed all those things, hey, you have not set all those things, so because of that the basic auth credentials are only this. So if you want to change it, you can change it. That's what it says, that it's recommended to it's recommended that you change it, but no worries on this. This is for our local development, so no worries on this. Now okay, let's go to this terminal. Okay, and let's check this once, docker compose ps. Now if you see, the Express is also running, the host port is mapped 8081, and the container port is also exposed. Here we have not done host port mapping. Okay, so everything seems to be fine now. This is exactly what we wanted. Okay, so now let's go open our browser and access localhost 8081. Let's explore this application. Okay, so let's open our browser and go to localhost 8081, and if you see the Mongo Express, you are able to access. Okay, so these are the default database okay, the MongoDB contains. Now if you want to create your own database, maybe let's say Compose is a database. If you want to create, you can create. Okay, so now we have our own Compose database for your application or microservice. Now we can have our own collection. Okay, so you can have some collection, let's say products. It says it's a collection. Okay, so you can create a new document. This is some ID. Now name of the product is iPhone. So you can give like this. Okay, so now you create a new collection, you create a new record. Okay, so in the products collection. So now if you see, this works. Okay, this Mongo Express seems to work just great actually. So once you are done with your once you started playing, once you're done with your development, you can easily go here and you can say Docker compose down to bring the entire thing down. That's it. Now there is no more database, there is no more Express. Okay, everything is like super fast, right? Hey guys, in the previous lecture we had created Mongo Express and we were playing with that. Then we had issued the Docker compose down. So as soon as you issued the command, everything will be removed. Okay, so they automatically it will be stopped. The containers will be gone. So now if you go back to your Express application, right? Okay, if you go to localhost 8081, of course nothing will be up and running. So you have lost the data at this point. Whatever the product, the iPhone, the document we had created, everything is basically gone. Okay, sometimes this is what we want, so that we can have always start from scratch. Okay, fresh data, we can do certain sometimes this is what you need for testing everything. Sometimes you do not want this. Whatever you do, you want to save them somewhere properly in your host. Okay, so if you want that thing, then go to Mongo, go to the description. They provide all this information actually. Okay, so where to store the data. By default, it will be stored, everything will be stored inside the container only. Okay, if you have not deleted the container, you can, if you restart, yeah, you can get the data. But if you have removed the container, the data is lost. So what we can do is, it says that by default Mongo seems to store the data inside data DB directory. Okay, so now we can do some host mapping so that we can try to keep the data. Okay, so in our host somewhere, so that whenever we Docker compose down, okay, we will not be losing it actually, because the data we are storing it in our host actually. Okay, so to keep our Mongo database documents, collection details, everything, so I'm going to create a directory here. I'm going to call this data. Okay, sorry, oops, I thought I created a directory. Okay, so data. Okay, this is how I'm creating. I don't want that here, I want this under this guy. Okay, so move. Okay, so here under this I'm creating a data directory. Okay, so now here what I'm going to do is that I'm going to use the volume mapping, right? Volumes, this is how we used to do, right? Okay, volumes. Here I'm going to say in the current location there is a data directory. Okay, in the current location there is a data directory. Map it with the container data DB directory, because the Mongo description, the document says that this is where the container they store the data. Now if you map it, so whatever the container is trying to store it here, we will be getting it here actually, so that we can always keep the data. Okay, so we will not be losing it. So let's save this guy and let's go back to our terminal again. Let's play with the Mongo Express UI. Let's bring it down and let's bring it up and see whether the data is present or not. Okay, this is what we are going to do. So let me clear this screen. Okay, so now I'm going to say Docker compose up, so it doesn't have to pull those images, everything is already present. Our Express is trying to connect again and again. Looks like, okay, at last it's able to connect. Okay, or Mongo Express takes some time actually. Okay, so now everything seems to be up and running. Now let's go back to our browser. now if I go to localhost 8081, I should be able to access Express. Okay, everything is running. Now we have to start from scratch, but that's okay. So compose, this is the collection I'm going to create. I'm going to do the exact same thing. Now I'm going to create compose is a database, products is the collection I'm creating. Okay, and under that I'm going to give one document. I'm going to call this name. I'm going to say iPad this time. Okay, so save. Now everything seems to be saved. Data is present. If I refresh, it's present. Now let's go back to our terminal. Okay, I'm going to kill this. I'm going to do docker compose down as well, so all the container is gone, network is gone, everything. Okay, now let's go back to your the data directory. Okay, if you check the data directory, now you see a bunch of files. Okay, this is not, of course, it's not created by us. So Docker has the Mongo database, that process seems to have created all these things now. Okay, so now it's fine. We have some data. There is something. Okay, let's not worry about it. Again, let's minimize this. Okay, let's clean this up. Now let's bring it up. Docker compose up. Now things seem to start. Our Express is exiting every time. Okay, finally, yeah, both are up and running now. So let's minimize this. Let's open our browser. Okay, so this is from okay, let's refresh this. Okay, this is okay, I'm refreshing this. Now if you see, I'm seeing the compose. Okay, the container is a new container. It was just created, but we are bringing the compose, we are bringing the products database, we even see the iPad. Okay, this time we didn't lose our iPad or iPhone. Okay, so this is good. So if you want to store the data, that is where the volume mapping, all those things come into picture, so that even if you stop the container, remove the container, we do not lose our data. Hey guys, in the previous lecture, by doing the volume mapping, we were exploring the Mongo database persistence. Okay, so even though it was working fine, this is one use case actually. It was working just fine. Okay, so however, we might want a slightly different use case. That is, whenever I start my Mongo database, I want an exact one collection with the set of records. Okay, this is a setup I need for testing purposes, something like that. Okay, so that you can push it as part of your Bitbucket or GitHub, so that it can be part of your version control system or your code base, your project code base. Okay, definitely you wouldn't want to commit this kind of junk files created by Mongo database. Okay, we do not like this. Instead, we want a proper script to initialize the database. You are getting what I'm saying, right? For example, in our Postgres or H2 and all, we used to have a schema SQL to create database to insert records. We want a script, something like that, not exactly a Mongo data directory itself. We do not want like this. So there is a way actually. So if you go to the Mongo documentation and Docker initializing a fresh instance, they say that. So if you want to initialize a fresh collection with the specific records, we expect a javascript.js file or shell script under this directory. Okay, if you have anything placed under this directory, we will be executing those. That's what they say. Okay, so using this, I'm planning to create one collection. Under that, we are going to insert set of records so that we can use this for testing purposes, something like that. Okay, let's explore that option now. I also want you to explore the Mongo documentation actually. Okay, so that is, so here, in order to programmatically create databases, create collection, to insert some records as part of our database initialization process, so we need to know some basic stuff. So if you want to do some advanced things, you can always explore this. But here I need this get sibling DB. So DB dot get sibling db, which will, this is alternative to the use database. So this will help us to create database. So they will give some code samples, etc., which will give you an idea. So this will give you the user database, something like that. Okay, and once the database created, we would like to create a collection. So the collection is tb.create collection. You have to give name. This is some options. This is basically optional. Okay, then once you have created a collection, so go to collection methods. Okay, so these are like database methods. This is collection method, what you can do inside the collection. So we like to insert a bunch of records actually. So there will be insert method, insert one, insert many. For example, if like to insert a bunch of records, I can give them in an array format like that. Okay, so these are the certain things we are going to do actually. Okay, if you want to again, if you want to do advanced stuff, take a look at this, and this will give you an idea. Using that, we can initialize our database. So let's get started. Okay, so I'm back to my VS Code. I'm going to get rid of everything actually. So let's delete everything. We do not want this. Okay, so the data directory is an empty directory now for me. Okay, so remove everything. Okay, or you can create another directory if you want to keep it. That's up to you. So under this, I'm going to create a new file. So this file can be called init.js or whatever it is. Okay, the name doesn't seem to be matter, because what they say is that if you have a bunch of JS files, we will be executing. That's what they say. So you can give whatever name you like. So first, what we are going to do is that we are going to create a database actually. db.get sibling db, and we are going to call, let's say, product service. This is our database name actually. This is how I am naming. So whatever the name you like to name, please give the name accordingly. Okay, so now once the database is created, now I would like to create a collection. Okay, collection. So in the collection, I'm going to call products. Okay, this is how I'm going to create a collection. Okay, now once the collection is created, db.products. Okay, under this db, under this collection, insert many. Okay, so this is what we are going to do. So this insert many is going to it actually expects things in an array, because it's insert many, right? So okay, yeah, it's an array, it's a list. So you have to pass the list of documents you like to insert. So this is a product, right? The product, I'm going to say name. Okay, so it's an iPhone. It's a price. The price is, you can, it's a string or number, it doesn't really matter. Okay, so you can give whatever you like. So it's like okay, let's keep it like that. Okay, then I'm copying this and I am pasting it here, and I'm going to say iPad. This is 800. Okay, now you can keep going like this. Okay, so Mac, and it's, you can say 3000, something like that. Okay, I don't know what unit is this, what currency is this, I don't care. This is a simple dummy initialization script. Now if you see, this is easily readable. Now it seems to kind of make sense, anybody can read it. Now we can commit this as part of our code base. Okay, so yeah, this is much better, cleaner than whatever we had earlier. Okay, so go to Docker Compose YAML. So the data is still correct. Okay, but this mapping is not correct. So we have to map it with the Docker entry point. Okay, so that's what the documentation says. You can check it. Docker entry point initdb.d. Okay, so whatever the file under this location, they will be read and executed. Okay, so if you, so I have one init.js. So when the Docker this Mongo container starts, it will be checking under this location. So it will be seeing this file. So ideally at this point, it should be executing all those things. Okay, this is the expectation. Okay, so now let's save this file, and now let's go back and try to spin up our Mongo and Express and see if we can see our the database collection, everything. Okay, please stop the existing the Mongo Docker Compose the containers, bring them down. Okay, let's start from the clean state. Okay, so let's clean this up. Docker Compose up. Okay, if you do this, things should start as usual. Our Express, it keeps exiting. Okay, finally it seems to have started. Okay, so now let's go back to our browser. Now I'm going to say localhost 8081. Now if you see, I'm seeing product service database. Okay, maybe I could have called this product DB or something like that, but doesn't really matter. As you know, it's just we are playing with this. And if you see, I am seeing the data, the collection, products collection. If I explore this, I am also seeing the data. Wow, this is cool now, right? So now I can bring it down, bring it up. The initialization script can be part of my the code base. This is super nice. So I can always ensure that I am having a predefined set of data for my testing purposes. Okay, so this is cool. Hey guys, in this lecture, I would like to share a quick trick or another approach to initialize our database. Okay, so in the last lecture we were doing volume mapping, etc., so that when the Mongo process starts, it reads the script and initialize the database. Okay, now there is another way. The another way for me, just to create a file. So this file is going to be Dockerfile actually. Okay, so I'm creating a Dockerfile under this. Okay, now the base image can be anything, right? So I am using Mongo as my base image now. Okay, then instead of doing volume mapping, I'm going to copy data init.js. Okay, and I'm going to place it under this location like this. Okay, so now I'm going to place it under location. So what I'm going to do is that using this, I'm going to create docker build -t wins docker Mongo, something like that. Now if I can create a docker image like this actually. Okay, dot something like this. Now if I do this, what do you think that will happen as part of the Docker build image creation process? It will take the Mongo as the base image, it will take the init.js and place it under this location, so that whenever you say docker run wins docker Mongo, so what do you think that will happen? So it will see the file and it will initialize the database for you. Okay, so you do not have to do volume mapping. So whenever you do this as your image, so you can always see your data every time. Okay, so this is also another way actually. So I have seen people doing this way, and I have also seen people doing this way. So you can follow any of this approach. Okay, now if you ask me which approach you use, if you ask me like this, I would say this is the approach I use actually. Okay, by doing this volume mapping is mainly because now I keep the initialization script separately, is part of my script, so that I have the complete control of updating whenever I want, and I also have the flexibility to choose a different version. For example, I can say 3.4 Mongo, 3.5 Mongo. I can always update here whenever I want. Okay, without rebuilding the image. Now with this approach, if you want to use a different Mongo version, so you have to update this 3.4 something like that, and you have to rebuild the image. Okay, so this is one issue with this approach. Whichever approach you like, you can go with these options. Okay, hey guys, in this lecture we are going to spin up Postgres and the adminer UI using Docker Compose. Again, go to Docker Hub, look for Postgres, search for Postgres, and you'll be landing on this page, so where you can get decent amount of information as usual. Okay, so they also have given the Compose actually, so you can directly use this, but instead of looking at that, let's try to create something ourselves. Okay, so the Postgres, the Docker image name is Postgres actually. If you okay, it's called Postgres. Okay, Then it expects few environment variables. What is your database username, database password, and if you want to have certain database name, you can pass it via Postgres DB environment variable actually. Okay, so this is what they are actually saying. So let's scroll down. Let's scroll down again. Looks like Postgres seems to store the data in this location. If you want to do by doing volume mapping, you can also store the data in your host. Okay, this is one way. Another way is to doing initialization scripts. So we can also create our own tables, insert records by using this script. So we can also do this way. We kind of explored both options for MongoDB. Now it's up to you. I want you to do this yourself. But now I'm going to directly use this to create a table, to insert some records, etc. Okay, so this is what I'm going to do. But what I would expect you to do this, instead of looking at this lecture, you try this yourself, some kind of an assignment. Okay, but if you are stuck, you can come back and check this lecture always. Okay, so now I'm back to VS Code. I'm going to create the Docker Compose for Postgres and the adminer. Okay, so now I'm going to create a new directory here. Okay, so I'm going to create a new directory here. I'm going to call this lecture 07 Postgres. Okay, like this. Okay, so under that I'm going to create a file as usual, which is going to be Docker Compose YAML. So version 3.0. Again, I can copy paste, but it's fine. Let's practice, okay, so that we do not forget this. Okay, services. The first one is going to be Postgres. So this is the name of the application or name of the service, as you know. So the image is going to be Postgres. Okay, and it expects a few environment variables actually. So we can say Postgres user. I'm going to call this, I'm going to give whatever name, okay, instead of admin. So maybe I'm going to give something like that. Okay, Postgres password, I'm going to say admin, something like that. Okay, then okay, so either follow that list approach or follow this approach, not mix and match. Okay, so see. Okay, then Postgres underscore DB. Okay, so this is the default database, which database you like to use. That's what it says. So I'm going to call this, like, say, product DB. Okay, let's keep it like that. Okay, maybe product underscore DB. Let's keep it like that. Okay, so this is for Postgres, and there is no port mapping, etc. Okay, so now we have to do some the initialization script, actually the CMOS SQL. So let's create a table and let's insert some records. Okay, let's create the initialization SQL. So for that I'm going to create a directory first. Okay, I'm going to call this data as usual, and under data I'm going to create a file called init SQL. Okay, so now let's create a table. Create table product, let's call this product actually. Okay, so then ID is a serial primary key. Okay, like this. So yeah, then name of the product, maybe varchar 50. Okay, and maybe the price is also, I might be interested, so it's a numeric thing, 10,2 decimal. Let's keep it like that, and it's not null. So different constraints. Okay, that's what I'm trying to do. Okay, whatever you want to do, you can do. So now let's insert into product table name and the price. These are the values I'm going to insert, because the ID field, since it's a serial thing, it will be taken care by Postgres actually. I'm going to insert set of records, maybe a TV, and the price is going to be 100, 12, something like that. and let's paste it few times. Okay, so this one will be iPhone, maybe it can, let's keep it under 600 5756, something like that, doesn't really matter. Okay, then it's an iPad, then we can keep it as a 300 4 5, something like that. Okay, some price. So let's save this, go to Docker Compose YAML. Now let's do the volume mapping. So volumes, here we would be saying dot data in the current location, data init SQL. Now sorry, okay, dot data, we would like to share the whole directory, okay, with the container directory, which is docker entry point init db dot d. Okay, so this is how we would like to okay, see, this is why I have to be extra careful. Okay, so docker entry point init db dot d. Okay, so this is how they expect. So now we would be we are sharing our init SQL with the container path now. Okay, so that's it, looks good to me. Now let's create the adminer. Okay, so this is another application, and the image is going to be, okay, everything is matching, right? Okay, ensure that they are in the same level. Okay, okay, so here the image is going to be adminer. Okay, and they have ports 8080, so let's map 8080 with 8080. Okay, again you can use any host port. Okay, it's not like you have to always match exactly, but this one is kind of easy to remember, that's why we do this way. Okay, and here this can be like two different applications, so you do not have to say depends on all those things, because when it starts it's not going to talk to Postgres. Instead we would be accessing the UI and we are going to connect it manually. Okay, so let's explore that option actually. Okay, so let's do this way, and let's save this, and let's go to our terminal. So I'm in my terminal. Ensure that you are in that directory where you have your Docker Compose you have just created. Okay, so great. So now I'm going to say Docker Compose up as usual. Let's hit enter, and this will be downloading Postgres, adminer, everything. So yeah, let's wait for some time. Okay, so looks like the things have started. Okay, Postgres is database system is ready to accept connection. What about this adminer? Oh, adminer is super quick, just one line log, that's it. Wow. Okay, so now let's go to our browser and try to access the application. So localhost 8080. Now wow, I see the adminer UI. Okay, so what is the database system we are trying to use? We are trying to use Postgres. Okay, and where is the server running? That's what they say. Again, now if you say localhost, it's not correct. Okay, if you try to do this way, maybe you can try, it will not work. Why? Because again, localhost is within that when you say localhost, it will look for the database server within the container, in the adminer container. It's not running there, it's in the container network. There is a container called Postgres, that is the container it has to talk to. So the server name is Postgres, give like this. Okay, and the username is Vince, that's what I had given. So just give your username, and the password is admin, this is what we have given, and the database is product underscore db. Okay, so if you click login, wow, now I see my product table created, everything. Okay, so this is cool. So now if you click on product, now we can see actually we cannot see okay, so select data. Now if you see, okay, now we can see the data. Okay, so yeah, So this is cool, right? So your Postgres database is initialized with all these records, database and everything. Okay, so now you can say Docker Compose down, everything will be gone. Again, if you say Docker Compose up, everything will be created in like in a matter of seconds actually. This is cool, right? Hey guys, let's quickly summarize what we had discussed in this section. In this section, we were mostly playing with the Docker Compose, which is a Docker utility to create Docker containers, networks, volume, port mapping, passing environment variables, etc. in a declarative way. Okay, so just by using a simple command, Docker Compose up, Docker Compose down, we can bring the entire infrastructure what you need, like to bring it up and bring them down. Okay, this is super cool tool to have. Okay, so there are few commands like again as I had said, so ensure that you are in the location where the YAML file is present, because when you use Docker, right, it's an imperative command. So whatever the command you are giving, so Docker the client will directly send it to Docker daemon, so we'll get it processed. Okay, but Docker Compose on the other hand, you are not giving anything, you simply say Docker Compose up. So in order to do that, right, Docker Compose, it has to go and check the file. So it will always assume that I have to read the Docker Compose YAML from the current directory. That is how it will assume. Okay, you are getting right. So if you are using a different YAML somewhere in your host, okay, so you have to ensure that you are passing the file as well, like this. Okay, so usually ensure that you are in this directory where the YAML file is present. Okay, so the Docker Compose up, it will spin up all the containers whatever you have in the YAML file, and it will create the custom bridge network. It will place them in the network, everything in a second actually, so that everything will be up and ready for you to use it immediately. Okay, similarly when you say Docker Compose down, then it will bring all the services down, so it will remove containers, networks, etc. Okay, super simple command, right? Okay, so Docker Compose PS, it will give you the list of all the services, corresponding status, what are all the ports, it exposes everything for each and every service. Okay, and Docker Compose logs, if you pass the service name, then it will print, it will give you the logging, all the log for that service actually. Okay, so that you can always check why it exited, what is the issue. So okay, you need all these things for debugging purposes actually. Okay,